Good morning, everyone. So, sorry, the entirely
Morning.
predictable has happened. That saying you can have 10 minutes exercise time at the start means people go, "Oh, we'll arrive 10 minutes." Oh, hello, 10 minutes late. But yeah, 10 minutes exercise time. We are here to give help if help is required. Please do ask. But yeah, we're basically just going to sit here and give support where we can for the next few more minutes. Hopefully, by the time that timer's up, everyone will be here, and then we move on. Have fun. Okay, time's up, and we are on 12, which is about right, I think. We have a regular late joiner. Probably a time zone thing, to be fair. um, so, where am I? Where am I? There I am. Let's move on. I hope you did get at least some of the way to this. If you just got connected, you've now got some more stuff to poke at, and you've got the steps to do it. If you do, as I say, as I keep saying, want support, do reach out and ask myself or Pratik. We are here to support, not just to talk at you and then walk away. So do try and get through certainly any exercises that you didn't do. Try and get through those in your lab time, because I think you get a lot more from it. And I mean, it's something we've said a few times actually, is arguably the value you get from this course is actually more in the time you've got in the lab afterwards, with all the walkthroughs and all the solutions, all of that stuff, than you'll get from me talking at you for 4 days. So please do get as much out of the lab as you possibly can. It really is the value of the course. And there we go. Look, we've got another pwn stamp, and we've got one machine left, which funnily enough, we're actually not going to poke at. So we move on now to VLAN hacking. Not the same thing at all. VLAN's used to sort of segment and isolate sections of a LAN in a rather different way. VPN's more about sort of joining stuff together. VLAN's about cutting it up. So we are going to quickly define it. So Cisco, probably best place to make this statement than anyone. A VLAN being a group of devices on one or more physical LANs that are configured to communicate as if they are attached together, when in fact they're located on different segments. So because VLANs are based on a logical instead of physical connection, they're very, very flexible. And so we can create this situation where we have all of these physical LANs all over the place, but actually logical LANs, either being a whole bunch of those connected together or one of them broken down into separate segments, or both, combination of the two. So VLAN discovery then, why do we use them? Well, it is primarily for isolation. Oops, didn't mean to do that. It is, as a side effect of that isolation, really useful for security, flexibility, and traffic and load balancing, but primarily it is all about separating off these sections of the LAN into separate sections. The thing about VLANs is it doesn't take much to screw it up, so there is a huge scope to completely break that isolation down to even the smallest of errors. So in order to learn the basics, we're going to need to, in order to understand VLANs, we're going to need to learn a few basics. So we're going to need to look at trunking and the protocols involved. We're going to need to look at 802.1q tagging, which I'll explain in a moment. And we need to talk a bit about virtual interfaces and how we can use those to abuse VLANs. So trunking is basically the concept of having a switch that handles traffic for multiple VLANs being able to communicate with other switches and send that traffic for multiple VLANs down a single connection. So this switch here hosts, has hosts connected in VLAN 1 and in VLAN 2. And this switch here has hosts in VLAN 2, and this switch here has hosts in VLAN 1, which means this switch needs to handle traffic for all 3 of these VLANs. And this switch needs to be able to tell this switch to send traffic to this switch and this switch for the appropriate VLANs. What that means is that this connection here and this connection here and this connection here and this connection here are trunk ports, which basically means they are connections that are capable of carrying traffic for those VLANs and allowing this switch to differentiate between which VLAN it's intended for. So in order to do that, we tag the frames. So we use an 802.1q tag, which is an IEEE standard, to inject. It's literally just a little 4-byte tag into each frame that is sent from one switch to another switch, and it just tells them which VLAN they belong in. It is sometimes easier to think of it as a sort of a wrapper that goes around the frame. It is technically as a tag that sits inside it as part of it, but if you think about it as going around the frame, you're sort of like you receive it and it's in an envelope, and that envelope's got an address on it. The address says what VLAN it's in rather than just what host it's for. And the switch will then open that before passing it on to the appropriate switch at the other end and the appropriate hosts. So we use ISL encapsulation, that's inter-switch link, which is a Cisco technology, and we use SVIs, switch virtual interfaces, which allow us to handle, oh, I've frozen. Hopefully my voice is still coming through. Which allow us to handle traffic routing between VLANs and support what's called the bridging configuration and routing protocols, of which, oh, go on, there we go, of which there are many. We've got CDP, the Cisco Discovery Protocol, which is actually used by the various Cisco devices to communicate with each other. So CDP announcements are sent to communicate with various different other Cisco devices, and they're sent over VLAN 1, which is what we tend to call the native VLAN or the management VLAN. That is the VLAN that all the Cisco devices will hopefully all be communicating with each other over. And generally speaking, you want to keep other hosts off VLAN 1. So those CDP announcements, if we can access them, they're interesting. You've got STP, the Spanning Tree Protocol, which builds on network topology that sort of figures out the paths and tries to avoid loops and things like that. You've got DTP, Dynamic Trunking Protocol, which allows us to dynamically configure the switch port trunks. The point of this being that when we have, as we had in our diagram, what if I plugged a host into this switch that was on VLAN 3? I wouldn't want to have to completely reconfigure every single trunk port every time I moved hosts around. So we want our ports to be able to dynamically configure and dynamically work out what they're meant to be doing. So there are a few different switch port modes. You can have access mode, which basically says you are always configured purely for hosts to connect to. You've got trunk, which means you will always be a trunk. And then more commonly, you've got dynamic auto and dynamic desirable, which are the two Cisco modes that allow two switches to configure a acceptable trunk between them. Or if we plug a host in, it'll say, hey, this is a host, it should be an access mode, and so on. You then got VTP, the VLAN trunking protocol, which is used to transmit VLAN information and help our auto configuration actually happen. And again, that involves broadcasts on VLAN 1. So if DTP negotiates our interface modes dynamically, that means effectively the point of it is for when we have two ports, when we have ports connecting two switches, those two switches can agree between them on what the right way of doing thing is. Now, dynamic auto is the newer one. It's a default on newer Cisco IOS devices. Desirable is default on older ones. The thing about this protocol is that it's unauthenticated, which basically means if we connect to a Cisco device, we can send false DTP packets and effectively pretend to be a trunk. So moving backwards and forwards, left and right. So if we want to attack a network with multiple VLANs, what we basically are aiming to do is get traffic into other VLANs. We're trying to hop from one VLAN to another. So we achieve this by attacking the trunking encapsulation protocols. So the 802.1q tags, the ISL, in switch link. And there are two main ways of approaching this. One is switch spoofing, which is where if we're able to connect to a port that is in either trunk, dynamic desirable, or dynamic auto mode, then we can potentially inject DTP packets and negotiate that with that switch to behave as though we are now an 802.1q trunk. So we can basically pretend to be a switch as long as we've got a connection like that. The other is double tagging. And that is where we forward packets into the wrong VLAN with a second tag on, so that when the first tag is stripped, there will still be a tag remaining and another switch will read that and hopefully direct us into the other VLAN. We need to be connected to a access port, and we need to be on VLAN 1 in order to achieve this. So there's two different attacks that can take place in two different scenarios. We're going to start off with switch spoofing. So we are going to mimic a switch. So we're leveraging issues that exist within DTP configuration, not least the fact that it's an unauthenticated protocol. We're only going to be able to do that if the switch port is not in access mode. If both are in access mode, then it's certainly a no. If one is in access mode, it's a no. If both are in dynamic auto, then they will figure out what's going on. So as long as we are not in access or dynamic auto, and the other, the switch at the other end is not in access, we should be able to negotiate a trunk. So we're going to need a bunch of information to conduct this attack. We will need to collect VLAN IDs in order to learn what VLANs we can become a trunk for. We need to know what IP addresses exist. So look for gateways, look for hosts, look for anything you can spot across that connection. And we're just going to sniff and sniff and sniff for traffic and try and find all the configuration information we need. You've got various different sniffers for doing this. You've got T-Shark, TCP dump. You've got a neat tool called CDP Snarf, where we'll be able to pick up those CDP packets. Lots and lots of things. Once you find VLANs, you can run ARPScan. Now, historically, we used to have to run Yersinia to get ourselves into a mode that would allow us to perform an attack. And then we'd have to run ARPScan over virtual interfaces. And it was all very, very complicated. It's actually a bunch easier these days. You can run ARPScan with a -Q and effectively just throw it into VLANs that we're not even connected to. It's really cool. I actually don't know how it does it, but it's very, very clever. So once we negotiate a trunk link, we can identify VLAN IDs. We can add VLAN interfaces, virtual interfaces, onto our host to get into these ranges. So effectively, well, I'll give away. We're going to be looking at interface ETH1. So ETH1 is connected to a switch, which is in one of those modes that will allow us to negotiate a trunk. What you can do is add a virtual interface on top of ETH1. So for example, to connect to VLAN 1, you'd go to ETH 2.1 and so on. So that's what we are able to do. Once we've gained any kind of a connection, we can try and perform an ARP sweep across that connection on the against the target VLANs. And if you find hosts, you've got a path to another network. Go and try and take them over. If there are any other devices, so for example, Cisco devices, have a quick look to see if Telnet or if there's an HTTP port open or something like that, and see if you can exploit through those. They very often have default passwords. Default password on a Cisco device, super imaginative, it's Cisco. Just remember that this is an open door to a whole other network. There are going to be a few challenges. So we're going to cover weak passwords. Cisco's got this thing called Type 7, which are just a joke. We're going to look at cracking device passwords. Some pretty straightforward stuff once we get there, but just a little bit of uncommon sense along the way. So in order to analyze traffic, we need to find our interfaces and bring them up. So do an IP link, and you'll probably find that there is one that is not currently up. So if you see lower up, it's connected. If not, you need to bring it up with ifconfig ETH1 up, because it is ETH1. I'm giving that away. To load 8021Q module, you need to run modprobe 8021Q. You will need that to make any progress. And then, as I say, lots and lots of ways of sniffing, but I'm going to use CDP Snarf, TCP dump, and T-Shark. And then I'm going to attack, well, for exercise 1 at least, 8.1, I'm just going to run ARP scans. So here's what we want to achieve. I have lost, there it is. The ability to turn my camera off. Kind of need that. We need to identify protocols that are being broadcast by the switch or routing device on the network. You need to do a CDP Snarf, and well, I'll show you some tricks. Observe traffic, answer as much as you possibly can, find all of the VLAN IDs, and find the live hosts in the VLANs other than VLAN ID 100, because we'll attack that in the next exercise. So just a bit of a giveaway. The third octet in the IP address is generally the VLAN ID. It's a pretty common naming notation used for tag traffic. So 10.10.100.210 means it is host.210 in VLAN 100 within the 1010 range. Hopefully that makes sense. So let me just reconnect to the lab. And if I run IP link, there it is. There's your ETH1, which is not currently up. So we're going to need to bring that one up. That's straightforward enough. Ifconfig ETH1 up. In order to get anywhere with this, I will need modprobe 8021Q loaded. And then hopefully it should be as simple as running CDP Snarf across that interface. Now these will transmit roughly every 60 to 120 seconds, depending on the config. I can't remember what ours is, but we might be waiting a little while. So in the meantime, I'm going to also start running TCP dump. And you can see that's picking up constant traffic. And if you have a look at them, this one mentioned VLAN 100. There was one a minute ago, VLAN 50, VLAN 10. There's definitely one that mentioned VLAN 20, but I can't see it now. There it is. And there was something a bit more chunky here, a bit more bulky. And actually, it turns out it was this. So we've got our CDP, which we can now read properly thanks to CDP SNARF. A little bit clearer to read than this, I think you'll agree. And all of the junk that came with that one. So we can answer a few of those questions already. We wanted to identify protocols being broadcast and observe device name, IP address, platform details, and software version. So it is a Cisco IOS 3600 version 12.413B. It is a Cisco 3660, which is capable of being router, switch, and IGMP. It exists in the 10.10.100 range, and it is 10.10.100.210. Various bits of information there, as well as amongst all of this stuff. If I want to just get the VLAN IDs, you can sort of figure them out just by scrolling through this, but you saw it took me a while to find one, even though I knew it was there. So a slightly quicker approach is this rather neat little command here, which just breaks down our T-Shark output looking for some specific traffic, and we can see VLAN IDs. Oh, that was a big one. 10, 50, 20, and 100. And that's basically all of them. Now, at this point, historically, as I say, we used to need to run Yersinia and then mess about to get ARPScan to work. But actually, it's going to be so easy now. I'm going to just do an ARPScan -Q, and I'm going to target VLAN 10. So I then specify the interface, ETH1, and I'm saying, look inside 10.10.10.0/24. And we find there's 2 hosts inside that VLAN. I'll do the same thing for 20. So -Q20 and change the 3rd octet to 20. As I say, I've got no idea how ARPScan does this, but it's very, very cool. There's no hosts in that VLAN. Do the same thing for 50. And I think there's a host. Yeah, just one host in that VLAN as well. So we're going to stop there for this exercise. There is another exercise coming where we're going to poke at VLAN 100. That's where the interesting stuff happens. But I'll give you a few minutes, let's say 10 minutes for now, just to gain that initial set of data. And then I'll give you a bit longer on the next one, just to make sure you're all caught up. Good luck and have fun. Okay, so don't worry if you haven't completely finished this. We want to get to a point where you can get connected, but the next exercise is just progressing on the same line. So we will allow more time. It's all good. So we've discovered a VLAN, a set of VLANs in the 10.10.00/16 range, and we've discovered a Cisco device on 10.10.100 well, 210 and 220 technically. More on that in a moment. For the upcoming exercise, then, we need to make sure that we understand that for every VLAN, the VLAN ID is that third network octet. So if we are connecting to VLAN 100, which is what we're going to do, you must use the 10.10.100.0/24 range and assign yourself a static IP in that range. What that means is we're about to all connect our Kali hosts to the same VLAN. So we will need to assign a static IP that doesn't conflict with anyone else. The obvious way to do that, use your user number, as we have done all through this. So if you are user 20, assign yourself 10.10.100.20. If you are user 15, 10.10.100.15. Please take care to do that right, because otherwise we're going to have IP conflicts and it could all go horribly, horribly wrong. There we go. That's that. If in doubt, ask. We've identified an IP address of a device on VLAN ID 100. We're going to continue that by finding another device, which I sort of just hinted by mistake on here. Find the IP of another device in VLAN 100 using ARP and get telnet access to that device. Make sure you can ping the IP, you can read its telnet banner, and it is above 200 because this lab, it currently can't, but could take users up to like 160 something, so 170 odd. So anything below 200 is just another user. So it is 200 and above that are the devices we're attacking. Get enable access on that device. This is the one time I'll admit when that this exercise is a little bit contrived, in the sense that we've given you the hash in a really, really obvious place. Number one, I have seen things exposed in this way. And number two, it's just because we didn't want to create another convoluted way of gaining access to the hash, when realistically, it's the device we want to mess with. That's all we're trying to demonstrate. The hash could have come from anywhere. So it's a little bit like we've skipped a step, but you will find a hash, you'll have to crack the hash, you'll get yourself access to a device. Don't forget default passwords. And then you should find an additional. So you're going to find a type 5 to begin with, and then you'll find a type 7. I think that is all there is to it. What I'm going to do with this is I'm going to give you 10 minutes alone. Do I do that? No, I'm going to add myself to a network, demonstrate adding myself to a network. What happened there? First. And then I will give you some time. So make sure mod Pro Beta 2.1Q is loaded. You should have already done it. If you haven't, make sure you do. And then the magic happens when I do a vconfig add eth1 space 100. And what that does is it creates a virtual interface, ignore the deprecation notice, eth1.100, which we can bring up. And if I do an ifconfig now, you can see eth1.100 now exists. And if we then assign it with an IP address and net mask, so 10.10.100.user number, we can then query that, and you can see that that has now configured itself appropriately. And from there, we can just run an ARP scan across that interface, and it's scanning that virtual network, that VLAN. And I can see that a couple of you got connected. I can see that some other people are still left over from previous use of the lab. And I can see that there's 2 devices here that are of interest. So I want to try and connect to those. I'll give you one last hint. Perform a quick TCP scan looking for port 23 telnet. There's a couple that are open. That's the one we're interested in. See if you can get connected to it, and see if you can break in. So let's give you 10 minutes to get connected and get on there, and then I'll just show you how ridiculous Cisco devices are, or can be. How ridiculous they can be. Choose your words carefully. All right, good luck. Okay. All right, I have a mouthful of gummy sweets. I thought I had another 30 seconds. Oh, that is childish. Cool. So, I thought sugar might wake me up a bit. We're on my InMap scan. I found port 23. Let's just see what happens if we telnet in. And this is where I will readily admit that this is a little bit contrived. So to begin with, we want to gain access. Oops. Cisco being the default password on a Cisco device. Amazing. Isn't that ridiculous? And if we do a show priv, I'm not even allowed to query that. I'm not allowed to do anything at the moment. If I try show running config, I'm not allowed to go anywhere. So let's exit that and see if we can crack this hash. So let's whop that into a file, throw it at John, or throw John at it. Looks like it might already be cracked. I'm not sure if this applies to all machines. So if you get this same thing, no password hashes left to crack, it is possibly because it's already been done since the machine revert was created, which is a bit of an error on our part, I suppose. But if you ever get this error message, just do a John's Cisco hash -- show and you'll get the password. So don't panic too much. You can always get to it. So let's see what happens if I use that to try and elevate. So I'll turn it back in, Cisco, and then you can do enable, and the password being secret123. You can see my prompt has changed slightly. I did have a chevron. I've now got a £, or a hash, depending on which country you're in. You can tell I've got used to demoing to Americans. Show privilege. My current privilege level is 15. And with a level 15 privilege, I can do a show running config. And that will spit out all sorts of information. And you shouldn't be at all surprised, if I'm totally honest with you, to find some stuff in here. Someone else has had a bit of a play that possibly shouldn't be here. So I'm immediately going to take that away. And I'm going to tell you something interesting about Cisco Type 7 password hashes. They're not hashes. So there's a definition for hashes that requires a number of statements to be met. So a hash needs to be a one-way, non-reversible, sort of kind of like encryption, mathematical function that can't be reversed. You need a unique output per input, and a tiny change to that input should result in a significant change to the output so that you can't detect incremental changes and things like that. So if I put this hash into this Cisco Type 7 reverser and hit reverse, you could be forgiven for thinking that's okay, it's just because this is a common hash and it's basically looked it up on a rainbow table. But what do you think happens if I change the final 8 in that to a 7? Changes from password to passwork. 6, password. 5, passworry. 4, password. 3, password. 2, +1. 1, passworm. I don't know what to tell you. The idea that that is a hash is just laughable. So, and these devices, let's face it, they stick around for a long time. This isn't like, okay, well, that'll be deprecated in a couple of years. These devices are going to be in use for ever. Just going to give you 5 more minutes just to play with what I've just shown you, or to continue trying to pwn the other hosts if that's where you're at, or whatever it is you're doing. But After this, we move on and we move on to the next type of attack. Have fun. All right, cool. So I'm going to drag us forward because we've got another really cool exercise, and I actually think this one's awesome. So just a little bit of a explanation. This is the layout of the set of VLANs that we've just been playing with. So we had that single Cisco device, the .210 one, which is our gateway to all of these various different VLANs. There is nothing in VLAN 20, but VLAN 10's got a couple of machines you can attack. VLAN 50's got a machine you can attack. And then in VLAN 100, we also had this Cisco device that we've just been messing with. So that's switch spoofing. What about double tagging? Let's have a chat about double tagging. So as I said before, double tagging is when we send a double encapsulated 802.1q frame, which effectively means we've injected two 802.1q tags into the frame. We do need access to the native VLAN on an access port to do this. So if we don't have access to VLAN 1, this isn't going to work. So that is kind of the single significant limiter here. The other issue, though, is that it's a one-way solution. We are going to be sending traffic with two tags. It's going to hit a switch, which is going to strip one tag. It's going to hit another switch, which is going to see the second tag, trust it because it comes from the first switch, and it's going to forward it into our victim network. The host at the other end is not going to do the same back. We can't expect it to do the same back. We're not going to get any kind of responses through the same process back from our victim. So we're going to need to pick our attacks very, very carefully. So just to show you the basic example of how this works, you've got two VLANs. In this instance, we've got VLAN 1 and VLAN 20. Let me get my face out of the way. VLAN 1 being native, we are sat there as an attacker, and we are on an access port connected to this switch here. There's a trunk, there's a switch here, and that has access to VLAN 20. We send our packet double tagged. First tag says VLAN 1. It hits this switch, which says, hey, it's got VLAN 1 tag. That's fine. I'll pass it down the trunk to this switch. This switch then sees it's got a VLAN 20 tag and passes it into this VLAN. It's pretty much, oversimplifying a little bit, but it's pretty much as simple as that. There's a neat little Scapy one-liner that you can play with for trying to make all this stuff work. But we've actually discovered through some fairly major messing around that we can do this just using native virtual interfaces, pretty much just stacking them on top of each other. Sounds mental, but we'll show you the process. So a few things we need to remember. We need an access port on a native LAN. Without that, this won't work. They are unidirectional. We will not get a response. TCP requires a three-way handshake. So there is no TCP attack, HTTP, whatever, that will work. They need a three-way handshake. We won't get that three-way handshake because we won't get any responses. So really, it's UDP. We're looking at fire and forget kind of attacks when we can send a packet and just hope that it does what it's intended to do at the other end. If we want something back out of our victim, which of course we probably do, we're going to need to think about what other channels we might have for getting that response. The good news is that very often, the reason we find an attack like this works is because, I've got a diagram somewhere. Here we go. We're going to be attacking this victim machine here, which is in VLAN 20. This machine has a connection to the main network. So imagine, for simplicity, that this is the internet. So we're connected to the internet, it's connected to the internet. It's firewalled. We can't get any messages back into it. However, we've got knowledge that we've picked up from, I don't know, network diagrams or compromising other services. We've learned through whatever means that there is actually, that this machine is connected to a VLAN, and that we're also able to connect to that to that network. We're in VLAN 1, it's in VLAN 20. So effectively, if we can get our exploit to it, it can connect back out to us over this network. So there's quite often some sort of out of bounds channel for getting that response. We're just not going to get a response directly to us, which is why TCP won't work. But if we can exploit this over UDP, we can get it to then reach out to us over its other interface, the one that's connected. It's firewalled on the way in, but very often not firewalled significantly on the way out. So the exploit reverse shell can be obtained via some out of bounds channel. So there's a few steps to this. Number one, make sure you got ModPro 802.1q loaded. You should already, of course, so that's fine. Add VLAN 1 on top of our ETH2 interface and turn it on. So ETH2, the only interface we haven't messed with so far, is connected on an access port to this switch. We can specify we would like to be on VLAN 1, and because the switch is not configured to prevent that, we can just connect to VLAN 1 by doing a add ETH2 1 and then bringing up ETH2.1. We don't need to assign an IP address because we're just going to pass straight through it. What we can then do is add a VLAN 20 virtual interface on top of our VLAN 1 virtual interface. So you do vconfig add ETH2.1 20, and then we assign ourselves an IP and netmask. If config ETH2.1.20 10.0.20, and then your user number with a netmask 255.255.255. Bring that up. In order to interact with VLAN 20, we're also going to need to add a couple of little tricks. You will need to add a route to it because otherwise our device won't know how to get there. So we do an IP route add 10.0.20/24 via the IP address you assigned on device ETH2.1.20. You will also, because you're interacting with a remote IP you've never touched before, need to add a fake ARP entry for the victim's IP address. So we're telling you, giving away that the victim is 10.0.20.201 inside that VLAN 20. So we set up ARP-S 10.0.20.201, just stick a bunch of Fs in because it doesn't matter, we're tricking it anyway. And then we're telling it to send that to interface ETH2.1.20 and it will figure out how to get there after that. The vulnerability we're exploiting, again, we have to tell you this because you've got no way of reconning this. So you would probably find this because, let's say on the Linux host we just compromised, let's say that was sending logs somewhere and we went, hey, where's that sending logs to? And established it was sending logs to a device in VLAN 20. We can exploit a log4j, Apache log4j vulnerability. So log4j accepts serialized log events over TCP or UDP from other applications. And in 2017, there was a vulnerability discovered, deserialization, shockingly, affecting Apache log4j from 2.0 up to 2.82, where we can send our binary payload, which will be deserialized, and get code execution on the other end. I will give away, well, I'm going to demo it anyway, but I will give away that it's Commons Collection 6 in this instance. A bit of a Google would find this, but I have since learned that there is some quite misleading information out there. And I believe someone has exploited a similar vulnerability on a modified version of log4j, which is using Commons Collections 5. So the standard one is this one, which is Commons Collection 6. So double tagging then. We are sat on this host. As we know, we've got ETH0, that's your 192.168.usernumber.206 IP address, pointing out onto the main lab network. We've got ETH2, which is 10.0.20.x, which is what we're going to assign to it, or technically ETH2.1.20, pointing out with an access port to this switch. We assign that to VLAN 1 and then add VLAN 20 on top of it. Our packet will hit this switch with 2 tags. It will move on to this switch with 1 tag down the trunk, and that switch will just trust it again because it's come from another switch, and it will end up in VLAN 20 on ETH1, which is 10.0.20.201 on this host. This host has got the log4j vulnerability, and we can get it to communicate back out to us over ETH0 back to our ETH0 interface. Sounds mental. Just going to quickly show you, I did a Wireshark capture on each point here. So I captured here when I just sent a ping, an ICMP packet, I just sent a ping. And you can see that it's got 802.1q virtual LAN, ID 1 and ID 20. Once it's passed through this switch, there is an ID 20 left behind. 802.1q virtual LAN ID 20. And then once it passes through this switch, it now doesn't have any of those tags left. So you can see it's literally as simple as I was explaining it. It's not that I've massively oversimplified or anything. It genuinely is like that. Okay, so interface ETH2 connected to a switch in access mode. Let's assign VLAN 1 to it, assign VLAN 20 on top of that, attack port 4712 UDP on the vulnerable machine on 10.0.22.01 and get a reverse shell thanks to double tagging. So it's quite a few steps to it, I realize. Number one, make sure mod probe 21Q is loaded. If you haven't done it because you didn't do the previous exercise, then make sure it's loaded. If I do an if config, we've got all the ones we messed with so far. So we've got ETH0, we've got ETH1, ETH1.100, and we've got ETH2 sat here quietly. So let's do a vconfig add ETH2 1. We need to bring that up before we can go anywhere. So if config ETH2.1 up, I can then immediately add vconfig add ETH2.1 20. I can then bring that one up, ETH2.1.20. I need to give it an IP address. Don't forget to make sure that's your user number. And you do need to assign a net mask, otherwise this might conflict with the previous exercise. And if I do an if config now, you can see that I've got an ETH2.1.20 sat here with those details. As I mentioned, we will need to add a root, possibly is already there, and a fake ARP entry. And then it's deserialization. So I'm just going to hop over to my deserialization exploit folder, and I'm going to use ysoserial to create common selection 6. I'm going to call it reverse shell.bin. The only other gotcha here is you do need to do it in this order. So there is a simplified version of Netcat running on our victim host. And if you happen to send your exploit in a different order, it won't actually work. So the -e bin sh needs to be at the end. Not a particularly big deal. There are other reverse shell one-liners that would work, but just to keep things simple, that's what you need to do. And then I'm going to set up a listener. And I'm going to specify that I only want this to listen on 192.168.70.206. So I only want this to listen on my ETH0 interface. And the reason I'm doing that is because I just want to prove to you that that's where this, sorry, cat just jumped on the microphone. I just want to prove to you that that's where this reverse shell comes from. Then super, super cool way of sending the packet. I just cat out the contents of that file I just created, the payload I just created, and send it to dev UDP 10.0.22.01 4712, and that will send it to the host 10.0.22.01 on UDP port 4712. We're ready. We're going to hit enter, and my connection has come in 192.168.72.06 from 192.168.200.201. And if I run ifconfig on my victim, you can see that we've got those two interfaces, and that's how that's worked. So pretty cool, I think. I'm running as UID 1000 Java on this host. Hopefully that is everything you need. Let's swap up a, oh, my timing is absolutely spot on. I like it when that happens. We're going to take a break in 15 minutes. So we are due back from that break. That's 10:45, which means you've got exercise time until, there you go. So basically you've got 17 minutes exercise time and 15 minutes break. Take that in whichever order you wish. Let us know if you have any questions, and I'm going to be quiet for 31.5 minutes. See you in a bit. All right, welcome back. I hope you got some break time in, but equally, I hope you got to have a bit of fun with this because it is I like the fact it's a bit unusual, a bit out of the box. Of course, finding these is probably amongst the hardest of infrastructure hacks because you need so much information that can't be reconned. But having found one, it is really cool to exploit. And again, these things have been seen in the wild. It's not totally contrived and totally out of the realms of possibility. They have been seen. We move on. Clicky click. Just a word on mitigation, really. I'm not going to do much, as you know. I can't be bothered with blue team stuff. That's not me. However, in terms of access mode, if you set your switchboard mode to access, if you know it's only ever going to be used as switchboards, that's going to prevent any kind of trunking attacks. Set it to no negotiate and specify what VLAN that access port is for. You are creating potentially administration management because if that changes, you will need to change it. However, it does prevent people, as you saw in the last exercise, gaining access to VLAN 1, for example, which is a horrible, horrible situation you don't want. In trunk mode, again, you can set it to trunk, you can set encapsulation, you can set no negotiate, you can specify VLANs that are allowed on that trunk, and you can specify which VLAN is the native VLAN, and you want to keep people off VLAN 1. It's just so vital that you do that. So, pwns, awesome. We move on to cloud. So, this is the last section. It is a long section. I am wonderfully timed. I am ahead of schedule. This never happens. It's quite talky. We've got 4 good exercises in here, but it is quite theory heavy because aside from anything else, we sort of have to go back to basics a little bit with this one. So I'm going to try and make it as interesting as I possibly can, but given that my voice has not been great the last couple of days, I just want to get it out there now. I apologize that it is quite talky. So we'll start with what is cloud. So when people say, "Oh, cloud is just somebody else's computer," it's actually not true because it could be yours. What makes cloud is actually the way that you interact with it. So in the traditional sense, when we spin up infrastructure, you'd have to go and you'd have to physically or sort of directly interact with the host machines, and you'd have to define these services and configure these services. The joy of cloud is actually the degree of separation that you get from the underlying infrastructure. Cloud is made up of a whole load of services, and you access those services via, well, technically it's APIs, but you access it via the dashboard or via your command line tools that are interacting with APIs. And behind the scenes, there's all sorts of stuff going on, but you don't have to worry about it. So generally speaking, as the end user, you interact via the internet, although that's not necessarily true because you get private clouds that are hosted locally, but you interact with the services in a sort of an entirely separate way. You're not directly interacting with the underlying infrastructure at all. You're just making requests and things are happening for you. That's kind of what makes it cloud. So cloud then is this massive shared pool of configurable system resources that is decentralized. Most cloud providers have got multiple data centers in a given region and then a whole bunch of regions, and you can actually operate cross-region and stuff like that. Provisioning is fast. You're not needing to wait for hardware to be installed or for VMs to be copied and spun up and stuff like that. It all just sort of happens. There's a progress bar and then you have a VM. It's just like that. Access is entirely remote. We're not knocking on Amazon's data center doors and saying, "Hey, I need to come and do some diagnostics. Can I plug in?" That's not an option. And the goal really is, it's primarily, to be honest, around minimizing management. You're trying to offload as much of the hardware and in fact software as well management as you possibly can. Now you are also taking on a different type of management potentially, and we've created roles for cloud architects and stuff like that. But the goal is effectively to offload as much of that as possible. I've frozen again. There I am. So it is also a bit of an owning versus renting kind of scenario. So there is a significantly reduced upfront cost, and then you've got to work out whether long-term renting is going to cost more than buying. And really it comes down to the lifetime of things. So if I were to buy a load of hardware and I were to utilize that hardware to 100% of its capacity, 24/7, 365, from the day it's born until the day it's deprecated, what would that actually have cost me if I were to have done the same thing in the cloud? Theoretically, probably at that level, it would have cost more to use cloud services. But the reality is we don't use things to 100% capacity. Things do get deprecated when we haven't had them that long. And I've worked with organizations where we found critical vulnerabilities and they couldn't fix those critical vulnerabilities because their hardware was not compatible with the updated software. Hello. And not on the desk. I knew you'd do that. Their hardware wasn't compatible with the updated software and they hadn't had it long enough for them to write off the expense. So they were not prepared to fix critical vulnerabilities in their infrastructure because of the cost. And it was as simple as that. In cloud, you've always got the latest of everything. Is that enough of an advantage? Well, yeah, probably most of the time. It's that conversation, isn't it? How seriously do you take security? As long as you stay very, where's your excuse for not doing it then? If it's money, then you don't take security as seriously as you claim. So it can save you from situations like that. It's very, very flexible and scalable. And that is the other way in which it can potentially save you money. And I tend to take my tame example of a large e-commerce organization. So let's say during a year, their average requests per minute is set at one value. And then, yes. And then at a sales season, I mean, Black Friday is coming up, right? So let's take Black Friday, it's the obvious one. They're going to take many times that number of requests, an order of magnitude more, probably, number of requests per minute. And their hardware won't be up to it if they're only built to handle their standard daily usage. So what do? Well, you're going to have to scale up to cope with the largest possible number of requests. You need to be able to cope with your absolute peak. Otherwise, you're going to have customers who can't access your site and you're going to lose money. But what do? If you've bought that hardware, you're now stuck with it year round. Whereas with cloud, you can flexibly and elastically scale up to meet that demand and then scale back down again at the other side. And you're only going to be paying for it during that brief period where you're operating at well beyond your normal peak traffic. I'm not trying to sell you cloud, but that is an advantage that we just cannot compete with in traditional infrastructure. All right, so as I sort of alluded to, cloud can be various different types. You've got public cloud, which is your AWS, your GCP, your Azure. It's services that anyone can create an account with. Those are your public cloud providers. You can also manage your cloud privately, so you can actually have the entire infrastructure in-house or in a single data center nearby or whatever. It's still a cloud if you interact with it in that cloud-like way, but you can actually own it privately and be completely responsible for it. Hybrid is just a combination of the two. So you've got some public cloud and some private cloud, and they're usually connected together by some sort of data link. And then you've got community, which is basically a private cloud that's shared between more than just your organization, some community or other. So a bit of a comparison on those in terms of things like scalability and reliability and security responsibility. This is a very dangerously worded because we're sort of saying you offload some security responsibility, certainly not all of it, but obviously by going with private cloud, you are still responsible entirely, or someone will be. Oh, bless her. So I'm just going to probably skip past this because otherwise it just gets talkier and talkier. There are an absolutely obscene number of cloud services. So there's there's a song that was released, I want to say it was in September last year, by the guys at A Cloud Guru, and it was 162 AWS services in 2 minutes. If you haven't seen it, go check it out. It's hilarious. Not on the desk. Go on. Monster. So if you subscribe to the AWS updates, you'll know that is a constantly increasing number. So I dread to imagine what it's at now. Fortunately for us, we can categorize these down into 5 broad subcategories. So you've got software as a service. That is your sort of your Google Drive and your Dropbox, for examples. Oh, you nearly fell of that. Salesforce's online CRM is a brilliant example. I quite like the idea of using Office 365 as a go-to example because it is a suite of softwares as services, and I never know how to pluralize that. But that is effectively what it is. It's web apps. Software as a service basically just means web apps. Web apps that you're allowed to get an account with and have your own instance of effectively. So software as a service is those. A database can technically be software as a service as well, depending on the way you interact with it. If you ever interact with the underlying database management system itself, then no, it's a database. Probably more like a platform or something. But if you just have an account or have accounts, then yeah, it's probably software as a service too. Function as a service. We're probably all familiar with AWS Lambda. GCP and Azure call it functions. There's various different ones like that. It's basically you just write some code and it gets executed in this magical layer. Spoiler alert, it's a container. Container as a service. You've got various different container services and Kubernetes services from all the different cloud providers. Platform as a service. I quite like using Heroku as an example here. So if you've ever done any development, you've probably used Heroku. You can just sort of deploy your software to this platform. You're vaguely aware that there's no S under there somewhere, but you don't need to worry about it. You're just deploying to a platform. Elastic Beanstalk and App Engine are probably better examples in the cloud. So you can deploy various different services within the platform. S3 and the other storage container services do also count as platform as a service. Given that S3 literally stands for simple storage service, it's a bit of a misnomer given that it is anything but simple. Just to sort of explain myself, take the example that you can actually host an entire website using S3. So it is possible to do, and it kind of makes it a platform. Infrastructure as a service, you're now looking at virtual machines but hosted in the cloud, so EC2 and Compute Engine and so on. And with that decision over which to take, you are sort of balancing responsibility between yourself and the vendor. Now, we do have the proper model. Where is it? There we go. The proper cloud service responsibility matrix, going from on-premise through to software as a service, and you can see you're offloading more and more responsibility onto the provider. However, we have this rather amusing comparison to make. So I would liken managing traditional on-premise infrastructure to being a bit like being an IT guy and deciding to host a pizza party where you're going to make the pizza completely from scratch. By which I mean you're going to mix up that dough. You're going to knead that dough, leave it to proof. It will then need to be chilled. It will need to be brought back to temperature about an hour before you're ready to hand stretch those pizzas. I used to run a pizza shop, by the way, you can probably tell. You're going to have to hand stretch those pizzas. You're going to have to cook those pizzas, but your oven at home has got maybe 2 or 3 shelves in, right? So you're going to cook 3 pizzas at a time at the most. Only the middle one's going to cook, right? Because it's got to be in the middle of the oven. You're letting yourself in for a real pain. You've invited, I don't know, say 40 people, and you've got to make 40 different pizzas. By the time those pizzas are ready, the first batch is going to be freezing cold. The last batch is probably going to be burned because you're panicking about other things. By the time you have your party, you're going to be Monica in that episode of Friends where she falls asleep because she's so determined to be the best host. You cannot be all things to all people. And unless you work for literally Azure or whoever, the chances are you don't have all of the in-house expertise to cover every single part of this process. It's a huge number of things that you would need to be an expert in and have the finance to resource all of those different things. There is probably going to be a better way than trying to do everything yourself. It's never a great idea to try and do everything yourself because you have your own expertise. Let's say you're a software house, stick to software, don't try and manage your hardware too. The chances are you're not going to be as good at it as someone else whose job is to manage hardware. That's kind of the idea. So what you might do is think, I tell you what, then I'm going to move into infrastructure as a service because I still want all that control. I still want to do things the way I'm used to, the way I'm comfortable with. So I'm going to move into cloud, but I'm going to move, I knew she was going to do that. She's pressed buttons. What buttons has she pressed? She's ended my presentation. Okay, we're good. Oh, devil. You're going to move into cloud, but you're going to go with infrastructure as a service. And I would say that that's a bit like saying, hey, I'm still going to do everything. I'm just going to do it in a communal kitchen. I've offloaded the hardware and the virtualization, which is like the gas in the oven, but I'm still doing everything myself. Yeah, okay, I've probably got access to like an industrial catering oven, or maybe a proper conveyor belt impinger like they have in pizza shops. But there's still a limit over how much I can do at a time. And if, I mean, that's a two-man job, because if you're loading pizzas in the oven at the fastest rate that the conveyor belt will go, you need to be there at the other end in 6 minutes time to offload them. Otherwise they're all going to get crushed. Like, this is still very, very difficult. Just because you've got the right kit now, just because you've got this massive shared pool of resources and you can load all the EC2 instances you want, you're still managing an awful lot of stuff, and you're still taking responsibility for an awful lot of stuff. So I would suggest you move to the right one step further, go to container as a service. I'm going to say that's a bit like saying, well, what if we just said sort of bring your own type thing? You still got to cook them. You might not have to make them anymore, but you're going to have to cook them. There's still going to be massive limitations on what you can achieve. You're still responsible effectively for runtime and upwards with container as a service. Platform as a service is a bit like getting a takeaway. That's starting to sound a bit more like a party I can manage. All I got to do is get the beer in. Depending on where you live, maybe the takeaway will bring the beer too. How good would that be? You've just got to invite your friends, host the party, make conversation. I guess you've got the clean up afterwards. But why do that when you could go to a restaurant? All you've got to do is make a reservation, get all your friends to the same place, sit down at that table, and you'll be brought pizza and beer. You might have a bit less control over what pizza options are available to you, but this is starting to sound a lot more like you're going to get to enjoy it as well. And then software as a service is kind of like turning up to somebody else's party. You don't even need friends anymore. There's a joke in there, definitely, about software as a service and not having friends. I'm not gonna touch it. It's not worth it. But effectively, yeah, you just got to turn up and be interesting. So that is the point here I'm trying to make. On premise, you're responsible for everything from the physical security of the building that you're in, through to the servers themselves, networking, network level load balancing, the virtualization layer. You're configuring that OS, you're hardening that OS, you're maintaining that OS. You're responsible for the middleware, for runtime, for applications, the security of those applications, again, for maintaining and updating those applications. It's a huge amount of responsibility, and this is a number of jobs, realistically, a number of departments. So again, unless you are literally Azure or someone like that, the chances of you having the resource and the expertise in-house to do all of this and do it all right are slim. They genuinely are for most organizations, certainly most organizations that are not explicitly hardware and software specialists. So moving over to infrastructure as a service, you've offloaded that much. Virtualization below, that is now a responsibility of the vendor, but you are still choosing to maintain an OS. You're still got to pick that OS, set up that OS, harden that OS, configure that OS, maintain that OS in the long term, make sure it's kept up to date, and everything above. You could offload that as well. By going to container as a service, you're only responsible for the container itself, for the runtime, for applications installed within it, and so on. Platform as a service, you offload runtime as well. Functions as a service, you offload applications. That's not really a problem. You're just running logic that you've written in a container, independent of all other logic. And with software as a service, all you've got to do is manage identity and access to it, and everything on the client side. Be aware, though, that with this, it's potentially a bit of a split stack. So if I take Google Drive, that's Google top to bottom. It's Google software hosted on Google infrastructure. But a lot of the time, it's a third-party software as a service provider who is hosting their software on somebody else's infrastructure. It's probably on like Amazon or something. Who, at what point, where does the split lay? Is your software as a service provider using infrastructure as a service, in which case they are responsible for an OS? Do you trust your software as a service provider, not just to configure the software correctly, to have written the software correctly and maintained it, but also to keep that OS up to date? Now, at this point, it's a supply chain question. And what we're effectively saying is understand where that software as a service provider lies within that supply chain, whether they're responsible for everything on a platform or whether they're responsible for an OS. And can you trust them with that? Now, I'm massively cynical, so I'm going to be cynical right now and say, do you care? As long as you've ticked the boxes that you were required to tick in terms of due diligence and auditing your supply chain, if they later get rolled, well, yeah, if your data is exposed as a result of a supply chain attack, it's still bad for you, but it's certainly not as bad as if you hadn't done your due diligence and you were using an untrusted supply chain. It's certainly less your fault. You shouldn't lose your job. Your business will still suffer. That's inevitable. But how much really does depend on an awful lot of factors here. So I think it's an important thing to be aware of, but not necessarily make or break. It can depend. So, I need to get in here. Why have we written not only this, which is half a day at this point on the end of our AIH course, but in fact we've written a 4-day cloud security course. Why have we put so much into building on our cloud trainings in the last few years? Well, there's been a huge push, I'm sure we all know, in the last 4 or 5 years for organizations to, I hate using buzzwords, be on cloud or cloud native. You can almost hear the air quotes in my voice, can't you? So organizations that were forward thinking have been using cloud for a long time. We know that. But organizations, let's say government, military, financial sector, they all used to say, we don't use shared infrastructure. It's in our policy. We don't do shared infrastructure. Shared infrastructure can't be trusted. But in the last 3-4 years, I know that they are moving towards using cloud infrastructure. I know because I've worked with them. I've worked with UK government, US government, Australian government, Canadian government, UK and US military. I've worked with financial sector organizations in a ton of different countries. They are all accepting that cloud is the future, and we can no longer just say we don't do shared infrastructure. But it is shared infrastructure. That's what it is. Cloud services are just big, complicated shared infrastructure. And there are lots and lots of different offerings, and those different offerings all have different threat models. And the trouble is they're not isolated. We tend to, if we think back to say, I don't know, 10 years ago when we were still talking about a perimeter, we used to think that our organization had this perimeter, and if we had firewalls on the outside of that, we could treat the outside as untrusted and the inside as trusted. We know now that and it's really only been in the last couple of years that we've moved on from that. We've moved to this sort of zero trust model where we accept that there is no perimeter. We shouldn't trust from one service to any other service. We should never trust. But we now start to think of all of these services as being entirely isolated. Okay, so if we're in a zero trust space, that means this service is isolated from this service, is isolated from this service, and we've kind of got all these interconnected little circles now. I don't know if I'm producing the mental image I'm trying to produce, but historically, one big circle with a big ring around it, that was our infrastructure, that was our perimeter. Now it's lots of little circles with a line drawn between them. But actually, that's not how it is. When you're using a cloud environment and you've got a cloud account, which is responsible for lots of different services, that means those services are connected. So the mental image I'm trying to give you now is of this threat model that is not just a circle, it's a bulging, writhing mass of blobs of different threat models, but they're all pushed together and all squished, and they all intersect in weird and wonderful ways and overlap in weird ways. Hopefully you're getting a sort of a monstery, gross image at this point. That's what I'm going for. I'm not a fiction writer, leave me alone. So a misconfiguration in any one of those services can increase threats, not just to that service, but to your entire cloud environment. And a lapse in security, as we know, the whole reason we talk about security, can cause a loss of money, data, reputation, and resource, intellectual property. And it can be so much worse than just, hey, one service got compromised, and so the data in that service got compromised. It could be a lot worse. Now, in terms of cloud-specific hacking, there's sort of two main things I want to talk about. Cryptojacking is this huge thing where if we gain access, or if an attacker gains access to your cloud environment through a compromised cloud service, and they're able to interact with your other services, they can potentially basically go crypto coin mining or whatever on your bill. You're paying for it. It's your services that are doing it, and they're the ones profiting. It's quite a big thing. It's quite common. It's happened a whole bunch of times to a bunch of quite high profile organizations. It's happened to Tesla. So it's a well-known and severe issue. The other one I want to talk about is kind of the ultimate cautionary tale, I think, which is where a business went bust overnight because someone got access to a single set of AWS credentials. The full story is basically that this organization, Codespaces, back in 2014, they were quite forward thinking. They were hosting your source code in their environment, and you could perform all sorts of tests and make changes on the fly and stuff like that. It was really good for developers. They suffered what began as a denial of service attack. So they started fighting fires with this denial of service attack, trying to get their services back online. But it turned out that was a front. The attackers had got hold of some AWS creds. We don't, I believe, know how, whether it's through phishing or they were accidentally exposed or whatever. They got these AWS creds and they got into the EC2 dashboard. My assumption is the initial plan was probably to steal intellectual property. That's the obvious reason you attack an organization like that. But once Codespaces got wise and they started trying to shut down access and change passwords and suspend users and stuff like that, the attackers went into what I can only describe as destruction mode. And they started deleting instances and volumes and databases and stuff like that. Problem is, by this point, so Codespaces were like, we're not too worried. We're going to have a period of downtime, but we've got backups. We've got everything backed up. We've got snapshots of all of our instances. We've got backups of all of our volumes. Trouble is, those were managed by the same master AWS account. And by this point, the attackers had escalated privileges within the AWS account and had control over that stuff too. So they deleted the backups. They deleted the backups of the snapshots of the images of the virtual machines. They deleted all of those volumes. They deleted backup databases. At the end of that one night of attacks, Codespaces had nothing left. And in the morning, they basically had to issue a statement that said, we've lost all your data. We've lost all your trust. We have nothing to build back from. We don't have our own systems. There is no point in us continuing. But the cost we would incur in building back and regaining your trust is just too much. It's not worth it. And so this company literally went bust overnight, thanks to a single set of AWS creds. That, if that's not the ultimate cautionary tale, I don't know what is. Okay, I'm talking too much. So, quick comparison: conventional infrastructure security from a pen test perspective, as opposed to cloud infra. Conventionally, we needed approval from whoever owns the infrastructure. So you would call us, you would ask us to do a pen test, you'd give us permission to do the pen test. That would be that. In cloud, you don't own your infrastructure either. The service provider approval is required. Now, there are pre-approvals in place these days. Number one, there didn't used to be. Prior to 2017, we needed to submit a request form for every single pen test, and it was a nightmare. Number two, the pre-approvals that are in place actually do come with significant limitations and caveats. More on that in a slide or two. Oh, next slide. If we come across IDS, IPS, stuff like that, we can put that in your report. We can say, hey, fantastic, we were detected by these systems and they started throttling us or blocking our IPs. We can then say, that's fantastic. Now, can you please put us on your allow list and let us perform our test? If you stop this stuff from stopping us, then you'll get more coverage in less time. If we start having to bypass IDS and IPS, it's just going to make our tests take a lot longer, and you will get a less thorough test. With cloud, if we start looking like any kind of denial of service attack or an attack sending too much traffic volume, we're just going to be blocked. The ban hammer is going to come down and it's not going to be lifted. That's going to be the end of the test. So we have to be very, very careful what we do and what it looks like we're doing. Conventional network attacks, pretty much IP based. You might have some external host names and we might try and break through those into your internal IP space. And we'll be looking at mostly private IP addresses. With cloud infrastructure, most IP addresses are going to be public because most of the time that's how you interact with those services. We're going to rely on DNS very heavily for discovery. Pretty much everything will have a DNS name assigned, even if it's just the sort of the basic ones that are automatically assigned by the provider. You can have internal IP address space. You can set up a virtual private cloud. But even that must be accessed using some external public IP addresses. Business continuity and disaster recovery is pretty much your problem with conventional infrastructure. You need to have made a plan, you need to have had that plan checked and perform tests on it and so on. We have a tendency to rely on the cloud provider with cloud. We sort of assume, oh, it's in cloud, therefore nothing bad can happen to it. And we know in recent times that is not the case. A single data center in Prague burnt down, and the number of different organizations who had huge chunks of their estate go offline thanks to a single data center going down was pretty mind-blowing, given it wasn't even, you know, one of the big three cloud providers. It was a huge deal that this data center burnt down. So just because your stuff is in a cloud data center doesn't mean that data center is somehow like physically floating above the planet. It's still a building somewhere, and things can still happen to that building or to the connection to that building or to the country the building resides in. So we do still need a continuity plan and disaster recovery plan. I know that AWS, you can set your services up so they're replicated across regions or across availability zones within a region. That's not the default behavior. You need to pay extra for that. So if it's business critical, make sure you've actually planned for this stuff. Just to give you another example, and I'm picking on Google Drive again, we tend to think, oh, I've stored my data backed up in Google Drive, therefore it's safe, therefore it's not going anywhere. And yeah, the reality probably is that your data is probably striped across arrays all around the planet, but that's done for Google's convenience. If you actually look in your terms and conditions, especially if you're not paying for enterprise level protection, your data, there's no guarantee your data is on more than one drive. So Google could suffer a random drive failure, which could happen to be a drive that contains some of your business critical data, and that data could be lost forever, unrecoverable. As I say, chances are that's unlikely, and I'm sure they suffer hundreds of drive failures a day, given the amount of estate they must have. But the assumption that your data is safe is 100% flawed. With conventional infrastructure, the reason I have a job, the reason security is such a thing is because we're so concerned about data loss, intellectual property loss, reputation loss, and so on. That all still 100% applies with cloud infrastructure. Of course it does. There is an additional threat that we didn't really have with traditional infrastructure, which is the threat of service abuse, which could lead to either your services going offline or massive bills. And you're not going to get forgiven for a huge bill that's run up by an attacker going cryptocoin mining on your dollar, because that cost has been incurred. The service provider has provided that services. The heat that cryptocoin mining produces has been dissipated. Someone did that. You've contributed to global warming. You've got to pay for your for your services. It doesn't matter, but it wasn't you. You left your services open or let your creds get exposed. The final thing I want to say is, over the last 4 days, every vulnerability I've discussed and every vulnerability I've ever reported on a report, I've never found a 0 day. I'm going to hold my hands up and say I've got no CVEs to my name, right? I've never found a 0 day. Therefore, every report I've ever written has basically been a list of missing patches or known misconfigurations. Now, several of my colleagues have got a bunch of really interesting CVEs. The fact that I haven't, that's a conversation with Twitter, or about whether I can still be considered an expert or not. But the reality is the vast majority of issues that we find and exploit revolve around something that could have been patched or could have been configured differently. And so when we write a report, we tell you to fix it in terms of patches that you need to apply or configurations you need to change. That is the nature of pen testing the vast majority of the time. With cloud infrastructure, that of course still applies, but the goal of our offloaded management, if I hop back over here, is to offload as much of responsibility for as many of the things that need patching and configuring as possible. So our goal is that the cloud provider is going to apply those patches, and they will apply those patches and change those configurations in a timely manner, because that is their bread and butter. That is like the core responsibility that they have to you, is to maintain their systems appropriately. So missing patches at least should drop way down that list. Of course, if you're managing your own OS because you've gone with infrastructure as a service, because you've ignored all of my advice, you are still going to be responsible for patching. But by offloading as much of that responsibility as possible, patching should drop down, and it really is all about misconfigurations in your cloud environment. And the one particular type of misconfiguration, exposure of your cloud management or metadata APIs. So that's going to be a huge part of what we talk about. Quick word on legalities. So as I mentioned, prior to 2017, we had to apply for permission for every single test of any service that was hosted in the cloud. As of the 15th of June 2017, Microsoft led the charge on growing up a bit and no longer required pre-approval to conduct penetration testing of Azure resources. You can fill out a notification form, but it is just that, it's notification. The only thing is that you do need to comply with their cloud unified pen testing rules of engagement, which it turns out does apply some limitations over what you can do. Similar story, I can't remember exactly when, but Google followed suit. If you plan to evaluate the security of your cloud platform infrastructure with pen testing, you are not required to contact Google. You just have to abide by their acceptable use in terms of service. They also say, please don't let your tests affect other projects, because obviously if you start messing with their tenants, they're going to get upset. Interesting one with Google. If you find a vulnerability in Google's estate, you are effectively automatically enrolled in their vulnerability rewards program just by being a pen tester of other stuff. So that's pretty cool. AWS, they were the last to do it and the least sort of both feet in to do it. So permitted services, you can conduct security assessments against this list of 8 whole services. Wow, thank you, AWS. My problem with this is that the vast majority of time when organizations come to us for a cloud pen test, we tend to have to steer them towards the config review first. Before they waste money on having a pen test, most organizations are quite naive still in their cloud usage. And for example, they'll come to us and they'll say, hey, this is what we want tested. It's hosted on EC2. And we could conduct a test against their EC2 based application and find that we've now gained access to 16 other services that they didn't mention, because they work on the assumption of what we should be able to access, not what we will be able to access. And if one of those services is outside of these 8 categories, and to be fair, they are broad categories. It's not like, oh yeah, there's 160 something services and they've listed 8 of them. They are broad categories that include a number of services. But if it's outside of those, we've got to stop the test. We're now out of scope. So unless you know exactly what we're likely to interact with, and if it's not on that list, you've gone out and got prior approval from AWS, there is always a danger of that happening. Not only that, but there are some prohibited activities, and this does, to be fair, apply pretty much across the board. But no DNS zone walking, fair enough. No denial of service, as I said, that's a reasonable requirement, if a somewhat ambiguous one. No port flooding, no protocol flooding, no request flooding. I would define an Nmap scan as falling within those. If I can't even conduct an Nmap scan against your endpoints that are hosted in cloud, just what can I do as a pen tester without potentially upsetting AWS? Now, I normally at this point say I've never heard of anyone being blocked from finishing an AWS test because of Nmap. It's just that it puts you in a gray area, and I make some comparison to the 2 guys that were conducting a physical pen test of a government building in the States a couple of years back, and ended up getting arrested. And it turned out that although they had permission from local government, it was a federal mixed use building and they didn't have permission from federal government, and so they were nearly charged. All of this. Trouble is, I now have heard of an instance of someone being banhammer brought down and an AWS test having to be stopped because of an Nmap scan. I now know that it has happened, and that's insane. So even if it's not happened to me yet, I'm treading a gray area every time I perform a pen test on a cloud environment. And I'm sorry, but that's not right. I shouldn't be being put in that position. So the AWS testing request form is horrible. Now, I don't know, I haven't filled one in for a while personally, but I know that a couple of years back, the last time I did one, you still had to sign in using the AWS root account to do it, which immediately puts most clients at a disadvantage because they're like, oh, well, who's got access to that? Oh, I don't know. We all use IAM roles because we follow the best practice guidance from AWS to not use the damn thing. So you've got to find someone who can sign into the root account. They've got to fill in a form. AWS come back with all sorts of queries. That ends up in the client's spam folder because the person who's filled in the form isn't directly involved in the pen test anyway. It's an absolute nightmare. And by the time the test starts, you haven't got full permissions and the test gets delayed. And you can tell this has happened to me a bunch of times. So testing on cloud environments is a minefield. Despite these pre-approvals that are in place, despite all of that, it is still not straightforward. And there are times when it goes horribly, horribly wrong. Rant over, move on. We're going to map a few terms, conventional infrastructure versus cloud. So your self-managed servers, probably now EC2 instances or virtual machines or compute engines. An internal network, you can set one up as a VPC, virtual private cloud, or as you'll just call it, a virtual network. Your firewall appliances do still exist, but when we're talking about in the most simple sense of being able to block ports or open up access to specific IP addresses, you do that using security groups APIs. Google does call it a VPC firewall, but it's using the APIs to enable and disable access. The open network share issue, that's kind of a trope of pen tests. You know, when we connect to your network, we've got no authentication at all, but we find an open network share that's got public access and it's got a text file with plain text credentials in it. That kind of trope. Again, it could still exist in cloud. You could set up a network share, but we're going to be looking for your open S3 buckets and open other storage containers. That's the sort of the famous issue where we find sensitive data exposed to anyone who cares to find it. Event logs and syslogs, I'm hoping that all your applications are logging, but we're going to be looking for your unified logs. So your sort of, wrong way. Your CloudWatch, your CloudTrail, your Azure's diagnostics and activity logs, your Stackdriver. I always find it amusing, but Azure and Google's names for most of their services are really unimaginative, with the exception of Stackdriver, where Google have put all thought into all imagination into coming up with a name that sounds like a medieval siege weapon. And getting domain admin, the keys to the kingdom, that I won the pen test. How did your pen test go? Oh, I got domain admin. Ah, fantastic, you beat the pen test. That kind of trope, there's a bigger boss. We're looking at AWS root user, your GCP super admin, your Azure tenant admin. Having that complete control over the cloud account, we're bigger than the domain admin. There is a bigger boss. Just a few more. Servers are now services. We're less interested in your domain and domain admin as we are in your subscription itself and subscription admin. When we did pass the hash on Windows, it was this amazing thing where we were able to retrieve effectively a token, a hash in that case, from memory. And we didn't need to know credentials. We could treat it as credentials. We generally won't find usernames and passwords, apart from our initial access that we might gain from someone exposing usernames and passwords or phishing. Generally speaking, we won't get usernames and passwords to expand our access in the cloud environment. Instead, we're going to do a lot of credential pivoting, which basically involves pulling service account tokens, temporary security tokens out of various different roles, and then using those to configure our tools and allowing us to pivot across systems within your cloud environment. Private IPs will mostly be replaced with public IPs. We've sort of already touched on this. And most of our attacks, well, against Windows, it was all RDP. Against Linux, it was mostly SSH. We're going to be looking at management APIs. Instead of needing SSH or RDP, API access is enough. API access will get us all the access we need. So, talk done. Let's start talking about enumeration. So there are two sides to this. You've got asset enumeration, looking for the actual cloud assets and resources, which we can do through subdomain enumeration, looking for subdomains of your target domain, subdomains of SaaS providers, going through OSINT, looking at CT logs, looking for evidence of cloud resources in use. And then you've got credential hunting, looking for ways into those cloud resources. So username enumeration, potentially through the cloud APIs. AWS have had a number of interesting username enumerations opportunities over the years, but they generally fix them once reported. They generally change any kind of verbose error messages. Microsoft have a grand tradition of allowing username enumeration, and Azure is no different. So although you might come across rate limiting, which starts giving you false positives, There are very straightforward approaches to enumerating Azure's cloud APIs, in particular Azure Active Directory. Again, OSINT, this time instead of looking at Google and Shodan, we might be looking at GitHub and Bitbucket and so on. Google Dorking, or advanced Googling, as I prefer to call it. So we'll start with enumerating cloud assets and we'll look at DNS. DNS records can reveal a huge amount of information. MX records point to filtering or hosted email solutions. NS records pointing to your cloud registrars, your domain registrars, sorry, and your DNS protections. TEX records we use to validate our domains of various services, so we can get a list of services you validated with. SPF records listing entities you've authorized to send email on your behalf. That might be SaaS providers. We can get, a huge amount of information out of DNS records. Once upon a time, it was really simple. We could do a dig any. Any has been deprecated. So in an RFC last year, I think it was, DNS servers are no longer required to respond to any requests, but it just means we have to iterate through. So we can request SOAs, NS records, A records, MX records, TEX records, and so on, one at a time, or use a for loop. And we can learn a huge amount, as you can see from those. It's also customary and quite common to link not just SaaS providers, but in fact all of your cloud services to your primary domain by using a CNAME from subdomains. So you might set up helpdesk.yourorg.com, blog.yourorg.com, servicetest.yourorg.com, newapplication.yourorg.com. You get the idea. Those might all point to various different interesting services, maybe cloud services. Do be aware as well, but if you find a subdomain with a CNAME set up that points at a endpoint that doesn't exist or has been cancelled or whatever, there is the potential for a subdomain takeover. I'll talk about that a bit more once we get to SaaS, so I'm going to leave that for the minute, but just be aware that that is a thing. We can also do the opposite. So SaaS providers often provide you with a subdomain. So yourorg.saasprovider.com would be your portal. We can do a lookup using patterns based on your company name to try and find whether any of those exist on any of the common third parties that we know of. It's not going to be 100% accurate. Anyone can register. So this is a dangerous thing to give away. So I work for Clarinet. My wife's called Claire, and her email address starts with Clara. And so whenever I'm searching for my passwords, I get both, and it's very infuriating. So these sort of patterns are not necessarily 100% accurate, if you see where I'm going with this. So not all SaaS providers even give you a dedicated subdomain, and you may not link them all up. So there are going to be limitations to what you can do, but it's certainly an interesting exercise at the very least, and may well yield some quite interesting results. In terms of enumeration then, we've got some cool tools. We've got a tool called DNS Scan that will perform all of the DNS lookups. So it will check for name servers and text records. It will even attempt a zone transfer. It will also, you can give it a dictionary and a domain, and it will look up for subdomains of your domain based on that dictionary. Similarly, you've got Cloud Enum, which will do a similar thing, but within the cloud providers. So cloud providers have got some quite predictable formatting. So blob.core.windows.net is the set of domains for Azure storage accounts. So we could do some fuzzing based on the name of your organization and based on a word list and see if your org something or other .blob.core.windows.net exists. The same for s3.amazonaws.com, same for storage.googleapis.com. We can do those checks for storage accounts. It can also look for other services as well, like databases and things like that. So that's a really powerful tool as well. And when it comes to cloud providers, advanced Googling, I'm not going to say Google Dorking out loud anymore, really comes into its own, arguably. So cloud providers have these very rigid, predefined subdomains and structures that they use. So we can search within AzureEdge.net, core.windows.net, appspot.com, s3.amazonaws.com, and so on, looking for easily identified cloud services related to your organization. So we've got some examples, looking within s3.amazonaws.com and just looking for your organization name. And if we just do a basic search for s3.amazonaws.com, there are 5.5 million results. This is, I think, about a year ago, so quite out of date data, but 5.5 million results. That is all S3 containers that are open to public enumeration. Otherwise, the cloud providers would not be able to spider them. Sorry, not the cloud providers, the search engines would not be able to spider them. So if they show up on these results, that means they're set to public. Now, I know that some of them are intentional, and I know that not all public storage containers are bad, but I don't believe for a second that all 5.5 million of those were intentional. There is always sensitive data being exposed. They're always being found. So that is well worth a search. And you can go down to quite a fine-grained level, looking for specific things like SQL files, like text files containing the term database or Swagger, and so on, or even literally the token AWS secret. You've got CT logs. So we've sort of touched on this as well already. Mandatory logs for every time a TLS certificate is issued. Historically, we've had situations where TLS certificates have been misused or abused, got hold of and leaked. So we need a log of all publicly trusted digital certificates that we can search and validate the cert issuer, make sure the cert it hasn't been revoked, and so on. Certificate revocation is that's a whole other subject that we spend a long time on, but it doesn't work that well. So CT logs help us in that respect. But what that means is that for us during enumeration, it's a treasure trove of domain and subdomain information. We can just do a search of those public sources and find whether any subdomain exist, which is exactly how we found that test lambda.notsofruity.com address right at the start of the course on day one. So here we are searching CT logs, and we're searching victim cloud, and you can see AWS lambda.victim.cloud exists and so on, and has an Amazon certificate registered for it. So if we find some resources, we should probably have a think about attacking them then. So let's look at the cloud service attack surfaces. Yes, I named that. Yes, I knew I was going to have to read it out. Yes, I knew I'd trip over it every so often. So let's talk about first the data plane and the control plane. So we split the cloud platforms up into these two planes, and the idea is that these planes should be kept relatively separate. We should make it so that if we break into one plane, we can't move into the other. So the control plane is the plane with your management interfaces in. That's your cloud web consoles, your command line interfaces, your cloud APIs accessed by API key, your container managers, and things like that. There shouldn't be any data held in that layer. If I've got access as an auditor to your control plane, I shouldn't actually be able to access your data, only query your services. You've then got the data plane, which is your actual consumer cloud component. And if I compromise an application, that's in your data plane. I can gain access to the data held in that application, perhaps. But what I shouldn't be able to do is break out of that data plane into your control plane and gain control of your actual environment. That's the goal. Keep the isolation between those two planes. Because if I want to hack you, I will probably, unless you've exposed credentials, again, whether that's in a repository or phished you or whatever, if you've exposed cloud environment credentials, I'm going to get into your control plane. If I compromise one of your applications, I'm going to be getting into your data plane. And that is generally speaking the entry point. And if your data is what I want, that's where I will stay. Data plane's all good for me. If I want to gain control of your cloud environment, I want to find a way into your control plane. And most of the time, the way I'll achieve this is through leaked keys. Quite often, I will access those through that initial application compromise. If I get remote code execution on any cloud hosted application, I can potentially get access to temporary security tokens, effectively keys that will allow me to assume the role of your application, assume the permissions associated with it. So the way you interact with your cloud environment, and hence the way I will interact with your cloud environment, is through APIs. The cloud service providers all expose management APIs that are used to manage all of your services. Those are REST-based, and they are massive, complicated APIs. And they are largely undocumented, because generally speaking, the way that you interact with those APIs is not directly. You interact through either the cloud provider's web interface or via your command line tools. So generally speaking, it's the command line tools and the ways that you can integrate with those that's documented, rather than direct access to the very, very complicated APIs. So the cloud CLIs are generally written in Python. Azure being Microsoft, of course, there is a PowerShell version. So most projects that you see will be written in either Python or PowerShell or both. That said, there are SDKs for a whole bunch of other languages. So you will see tools written in other languages and Go and things like that. But from an outsider's perspective, your cloud applications, as I've said this before, and I think I alluded to cloud when I mentioned it, they'll just look like any other application. That application is an application. It's accessed at an endpoint. There'll be an IP address. There'll be a port. How do I know it's hosted in the cloud? Well, I could do a reverse lookup of that IP address and see whether it belongs to a cloud service provider. But other than that, it's not until I get into the application that I start to find things. And one of the main things we'd interact with, if I compromise any of your cloud services, any kind of service that you have in the cloud, is metadata API. So this isn't the same as your management API. This is a separate API layer that all the cloud providers give you that you can only access from within cloud services in order to gain access to your internal system and environment information. So they all have one. The way they work will vary from provider to provider, but a couple of things that are always the same. They're accessible over the normally non-routable IP address, 169.254.169.254. So you won't be able to access that from outside of a cloud environment, but from within any cloud service, suddenly this IP address takes you to the metadata API. They respond to HTTP requests, so you'll send a curl request to interact with it. They are generally a cascaded folder style content arrangement. So it's just sort of a cascading folder list of endpoints. When you go to one endpoint, you'll get a list of the next endpoints you can go to, and you can just add that into the address and so on and so on. And depending on the provider, there will be extra headers that you might need in order to get a response. And these are there to protect against reflected attacks like SSRF. So we'll start with AWS, arguably the most complete. I don't know if that's even still fair to say, but it's a big, complicated API. And it's particularly useful if we are interacting with an environment that uses IAM profiles and has assigned those profiles to services. Because what that means is from within a service, I can interact with the metadata API and potentially retrieve temporary creds for the IAM profile that's assigned to it. And that IAM profile is what you would use to club together your services, capabilities, permissions that you want assigned to your service. So for example, if I compromise an EC2 instance, which has the ability to interact with an S3 container or with a database, probably that set of permissions will be in the IAM profile that's assigned to the instance, and I can gain access to that through the metadata API, retrieve those credentials, and then I can assume those permissions and gain access to those other services. So if we can gain access to your IAM profile creds, we can do who knows what. Now with IAMDS v1, that's Instance Metadata Service v1, it was as simple as sending a curl request to metadata IAM security credentials and then the name of the role. AWS got sued in November 2019, and as a result, they introduced IAMDS v2, which added a mandatory header requirement for all requests. IAMDS v1 has not been deprecated. You can pick and choose as the tenant which one or both or neither you want activated in your environment. So IAMDS v1 can still and often still is present in environments. But if it's IAMDS v2, then all that means is you're going to need to follow a few more steps, and you'll need pretty much code execution to be able to do this, because you will need to retrieve a token by sending a put request to a certain endpoint with a header, which you can't reflect. So that is the point of these, and then send that token as a header, again, which you can't reflect, and then interact with the metadata API. With GCP, there is a mandatory header requirement for all requests. So this is why AWS got sued, is because GCP and Azure already required a header and AWS didn't. With GCP, it's simpler. You just need to add a header, metadata flavor Google. It's enough to stop reflected attacks. Arguably, this is massive overkill. I think it was AWS's knee-jerk reaction to the lawsuits, to be honest. With GCP, yeah, so you just provide metadata flavor Google, which of course, again, to provide a header, you will need code execution. It's worth noting that until very recently, GCP had v1 beta 1 of the API, as well as having v1. And v1 beta 1 didn't require that mandatory header. It was deprecated about 2 years ago, shortly before AWS got sued, hint, hint, but actually it wasn't removed. And the full deprecation got delayed and delayed and delayed, and it actually only disappeared. We've got a bunch of GCP services that we use for testing, and it only disappeared from the last one this summer. So it was meant to be gone. It got delayed and delayed. I think the final delay date was still September last year, but it wasn't until September this year that we finally didn't have access to v1 beta 1 on any of our services. Whether that means some people still have it or not, I don't know. but very interesting that was the case. Meanwhile, AWS are getting sued. Anyway, other interesting stuff you can put out aside from the service account token, root password, kube environment variables, things like that. Azure, similar story. Mandatory header is metadata true. And Azure for years now have required that header, and there's been no way around it. So you also go to metadata identity OAuth2 token, and you also have to provide some parameters with an API version and a resource, which would be management.azure.com, I think, for this particular request. It's also worth noting that although I mentioned the cascading folder style arrangement a couple of times, if you go to /metadata on Azure, you actually won't see identity as a suggested endpoint. You'll see instance, but not identity. You need to know this exists to find it, basically. So with Azure's metadata API, I would just say read the manual. In order to achieve anything, read the manual. You'll never figure it out. It's not straightforward. So let's start with SaaS then. Software as a service. The cloud service provider maintains pretty much the entire stack. It is a web app, therefore the attack surface is that of a web app. If you're not familiar with web app testing, the OWASP web app testing guide is a good place to start. We do an advanced web app testing course. I'll give you another completely shameless plug for that later. Call in a pen tester, whatever, but it's a pen test of a web app. That's what you're looking at with software as a service. The only specific scenario I want to mention is subdomain takeover, which I talked about earlier. So this is where a third-party service allows domain integration via CNAME. You create a CNAME entry on your own domain pointing to the third-party domain. So, you know, saasprovider.yourorg.com points to yourorg.saasprovider.com, that sort of thing. Very common if we've got a content delivery network. In fact, we do it at Clarinet. But if that CNAME entry exists, but the third-party section is not claimed, or it's expired, or it's cancelled, or for whatever reason it's available, then as an attacker, what we've got there is a trust relationship between a subdomain of the victim's actual domain and a subdomain of a third party that we could get control over, which means we could use that to prove ownership of a resource that we don't own. We could prove ownership of the subdomain of that victim's domain. And potentially, combined with other not uncommon vulnerabilities, misconfigurations, we could potentially hijack domain level resources, including domain cookies, from the main domain. So potentially very, very dangerous stuff. Moving on to function as a service, or serverless, another term I hate. To be absolutely clear, of course it's not serverless. There is a server. As I said, spoiler alert, it is a container. The point is that you don't have to worry about it. You just write your code in whatever language it is. The service provider will invoke it in a container when the request comes. The application logic gets executed in that containerized environment. That environment will later be destroyed, although when is anybody's guess. Data should never be managed by function as a service. There's no persistence. So if you are attacking function as a service and you gain the ability to see what container you're running in, and you send a whole bunch of requests, if that function is very, very heavily utilized, you will probably find that you swap between a bunch of containers over a period of time. You will probably find that it's got multiple containers running it, and that at some point one of them may disappear and a new one will spring up. If it's a very quiet function, I have at times been testing a function over a period of days and found that it is still the same container. It's not gone anywhere. It's not been dropped. My requests have been just enough to keep it running, so that they haven't haven't destroyed it to save resources. But at the same time, that means I'm now interacting with a single container for a period of time. So do be aware it's not necessarily as simple as container starts, function runs, container stops. So the flow is something like you trigger the function somehow. There are so many different triggers, but I'm going to give you a tame example of you can actually use function as a service to host a web server. So let's say the trigger is me hitting some DNS endpoint with a request. The function will process that input. So in my case, an HTTP request is going to process that request. It may need to interact with some backend, a database, a volume, whatever. It will produce some action or integration. In my example, that action would be sending me the HTTP response, I suppose. But it could be that it's integrated with other services, that it does other stuff, whatever. So the default timeout for function execution is set to 3 seconds. The point of function as a service initially, at least, was it was meant to be very, very snappy. And if your function took more than 3 seconds to execute, it probably meant something had gone wrong and it would be killed. So if I get a shell through a function as a service vulnerability, I've got 3 seconds to do what I want to do. That's not very long. So realistically, that's not probably the sort of attack you're going to perform against function as a service. That said, people have been using function as a service for some incredibly advanced, complicated processing. And due to the pressure from people, the service providers have given you the ability to increase that timeout up to 15 minutes or even more with some. Once execution is completed, it may or may not be on a different environment altogether the next time you interact with it. It's a container, so if you find a 0-day in the type of container that Google are using to host their function, potentially you could break through into the next layer. I suspect that's not very likely, but it's worth knowing you are looking at container-specific attacks. It's also worth knowing that Lambda actually doesn't have access to the metadata API. So back before AWS dealt with reflected attacks by responding to the lawsuit and introducing a header requirement, their approach was just to say Lambda doesn't have access to the metadata API. So instead, the access tokens for IAM roles are stored in environment variables when it's AWS Lambda. So you just need to take a different approach. Now, from the outside, these often still look like web apps, but actually because they're very, very different in the way they operate to a web app, the standard OWASP web application top 10 doesn't really apply. So a number of people have created serverless top 10s. OWASP have got one of their own, in fact, but this PureSec one is certainly worth a look. And what we've done is we've put together a basic Python shell, and I can show you it if I go the right direction. At tester.notsofruity.com. And what it does is it deliberately passes through whatever we put into the input box, which will hopefully load eventually. Tell me this hasn't gone down. This has never gone down. Phew. I was worried then. Okay, so whatever I type in here will be run on the underlying host. So I run ID, and you can see that within an AWS fast container, I'm running as UID 993, SPX user 1051. On G-Cloud, I'm running as UID 0 root inside that container. It's just different ways of doing things, and arguably the likelihood of you breaking out of this container is probably slim enough that it's not a big deal. Just to be clear though, if I refresh this, as you can see, that was run either in the same container or in a container where I am the same user. I'm going to go with same container. If I send a curl request to 169.254.169.254, AWS will give me 0 response because it doesn't have access to the metadata API from Lambda. G-Cloud comes back with the next possible endpoint to compute metadata. So if I stick that on the end of my request, we've got V1. Up until a couple of months ago, V1 beta 1 was still there. As it is, I have to go to V1, which of course is going to tell me missing required header metadata flavor. So if I take that, because I've actually got code execution, I can change my curl request -H metadata flavor Google, which means I'm now allowed to interact, and I can go to instance, service accounts, pick a service account. Let's go with the one that's not default because whatever, doesn't really matter. Token. You can see where this is going. That is the token that you would need to configure your Google command line tools to interact with the management API as whatever account with whatever permissions this service has. Now, of course, this service has no permissions, but if this was an application that did something and I was able to access that, there we go. I've now got access to the management APIs. With AWS, I just want the environment variables. So if I said set or printenv or cat out proc self environ, whatever, I've got access to the environment variables, and we've got an access key ID, a region, a secret access key, and an AWS session token. And that is all you need to configure your AWS command line tool. Google doesn't have anything very interesting. The only thing it really gives away is the name of the application. So feel free to have a play with that. It's tester.notsofruiter.com, but it rolls us straight into our first exercise, which is to access the web app at testlambda.notsofruiter.com/pyshell, give it a parameter name, and step 1, determine/prove, I know it's called test lambda, what service the application is running on, identify a vulnerability in that application, something to do with that parameter, and exploit that vulnerability to expose sensitive internal information. Remember, once you've figured out that it's definitely Lambda, exposing sensitive internal information is going to involve access to environment variables, not the metadata API. Okay, I'm going to give you a bit of time to have a play with that before I give you some spoilers. I just muted myself by mistake. Let's say 10 minutes. Done. And then I'll give you some spoilers and give you some more time. Have fun. So, spoiler time. If you're already smashing this, don't worry about it. But it's one of those ones where once you see it, you kind of go, "Oh, that was obvious." So, sorry. Okay, testlambda.notsofoodie.com, and you can see that basically whatever I put in the name is being spat out back to me. Test, test. That's not how you spell test, but okay. So I'm immediately imagining, okay, well, what can I potentially do with this? How is it responding now back to me? I'm going to try speech marks, quote marks, semicolons, stuff like that. And just to skip ahead to the part where I find something that happens, I'm going to just test semicolon ID, and the part after the semicolon doesn't get reflected back. So clearly something is happening. I don't yet know what, but what about if I try and dollar ID in brackets? That gets that run. So clearly there's some sort of command execution going on here. You can also, it turns out, URL encode things, and 3B will work. That is, I believe, a semicolon URL encoded. You could do a %7C, which I think is that a new line? I can never remember. Anyway, that works. We're able to get stuff run. So you could go with $set or $cat proc self environ. Or you could even just dump out the things we're interested in. $AWS access key ID, $AWS secret access key, $AWS session token, $AWS default region. And those are literally the variables that we want straight out of environment variables. Just to show you this from the command line, just because I think it's worth knowing. Bear in mind, Kali can't connect to the internet, so I'm now going back to my underlying host. And I can send a call request to testlambda.notsofoodie.com. I'll do a printenv, and then I'll reformat it and grep it, and I'll end up with session token, default region, secret access key, and access key ID in a nice consumable format. More on why I've done that later. Hopefully that makes sense. You should be able to pull whatever you need to out of there now. I didn't do the determine prove that it's Lambda, did I? Aside from the fact that I've just got AWS tokens out of it. The other thing that you can do is you can go to developer tools and then refresh. And if you have a look, you've got a bunch of headers that tell you that it's Amazon. So identified the service, identified it a vulnerability in the application, exploited that vulnerability to expose internal information. Let's just give you 5 more minutes in case all of that was completely new to you. And then we'll move on to the next bit. Right. Going to drag us forward. Hopefully you're okay with that and you're happy with that. Again, just ask if there is anything you're not certain about. But network status after fast exploitation. Look, I drew a little cloud at the bottom. And that is function as a service, pwned. In case you've got a bit of a taste for this, there are some awesome practice environments that you can get hold of. There is the Damn Vulnerable Function as a Service. The Damn Vulnerable series is brilliant. There's Serverless Goat and there is AWS Vulnerable Lambda, all well worth a look at. So we've just pulled out a token. We don't know what it does. We don't know what permissions it grants us. We actually don't have a straightforward way of finding out. So after extracting a token, we need a way of finding out what services are accessible to the token or tokens that we've got, what IAM capabilities it's allowed to interact, what are available to it, what service entities it's allowed to interact with. And when we initially started doing this, we thought, well, what about audit software? If we give the token to audit software, we'll get lots of access denied and we'll get success where it works. But the trouble is, it's actually not as simple as that. And audit software is not designed to ask the kind of questions we wanted to ask. So we needed a better approach, some way of enumerating those permissions. As far as we could find, it didn't exist. So we actually ended up building our own suite of scripts to enumerate AWS, Azure, and GCP token permissions. So we already knew that you can extract various information directly from the cloud APIs. You can do, for example, an AWS S3 API list buckets to list out all of the names of the buckets that exist. And if you have access, it will do that. If you do an EC2 describe instances, it will list out the EC2 instances you can see. If you do a Lambda list functions and so on. But these APIs are massive, as we've sort of said a few times now. So we needed to automate this somehow. So we just wrote these scripts that basically ask all the right questions. They're specifically intended for a pen tester to check the permissions associated with some stolen credentials. You can read up on this on our blog and you can download it from GitHub, which is exactly what I will do. I'm going to use the information from the previous exercise to find other services I'm allowed to interact with. So first step is you're going to want to clone github.com, not so secure, cloud service enum.git. You're going to need to do this to your local machine, your own machine, not the Kali machine. You would then go into cloud service enum, AWS service enum. And if it's the first time, you'll need to do a pip3 install -r requirements. You will need Python and pip to do this. I'm obviously up to date, so that's fine because I've run this a bunch of times. And then rather neat trick, much like my command I just ran up here, I'm going to get those details, but I'm actually going to save them to a file called token.temp. And then I'm going to read in token.temp and export them so that I don't need to do all this manually because I'm incredibly lazy. Having exported them, that has already configured my AWS command line tool. So you're probably used to typing AWS configure, and that will query for an access key ID, a secret access key, a default region name, and an output format, which you don't need that. The trouble is that doesn't give you the opportunity to give it a session token. And because these are temporary security tokens, we need that session token as well. So instead of using AWS configure, you have to export them as environment variables. What should I do? Print env instead. And you can see that session token, default region, secret access key, and access key ID have been set as environment variables. And then I should just be able to do an STS get caller identity. And it confirms that I am running with the assumed role shell PyShell. What I can then do is I can run AWS service enum.py from our suite, and we can feed it the access key, the secret key, the region, and the session token using those variables. And it'll go off and it'll enumerate that region for services that key can access, or those set of credits can access. And it's going to go for a while. It's going to check a whole bunch of services. You can see it's going in alphabetical order almost, and it's at C. So it's going to be going for quite a while. So I'm going to leave that running and then we'll go through it once you've done the same. So I'm going to put 10 minutes up for you to get yours started. It doesn't matter if they haven't finished by the time the 10 minutes is up, but hopefully 10 minutes is enough to start up a search. And you'll probably have seen already what the service we're looking for is anyway. Have fun. Reach out if you need any help. I realised the time. Um, right. Disregard previous. Tell you what, let's just really, really quickly put mine on the screen. Which is going to be a horrible process with that in front. So my checks are finished. It's run a whole bunch of checks. And among it was able to interact with Beanstalk and Route 53, sorry. It found some S3 buckets. So that's pretty much the intent. We will explore those after lunch, but basically let's just whop a lunch timer up. So we put our 1 hour lunch up. And then let's just take that up to 37 or something. I don't know. There we go. Hour and 5 minutes, we'll start talking again. Do get time away, but hopefully that will give you an opportunity to make sure that all of this stuff works the way you intended. I will see you in an hour and 4 minutes and 45 seconds. Okay, welcome back. So my timing was off for once. I'd been doing so well. Got to the point where I'd finished this demo and we'd established that there was definitely a bunch of S3 buckets accessible to this token, and then realized it was lunchtime. So where we're at now, hopefully you've managed to run an enumeration on those tokens, and you're in the same position as me. So let's move on to, not mega shocking perhaps, platform as a service. So this is when you have access to some provider maintained platforms. So Heroku, App Engine, IIS Azure, but S3 in this case are all examples. It is, of course, significantly less flexible than infrastructure as a service, but it does give you more control, depending on the platform, than you might get from function as a service or software as a service. And arguably, it's along similar lines to shared hosting environments. I always think it's a very dangerous thing for me to say, but I'm going to go out with it anyway. I think you could argue that cPanel is a form of platform as a service. I haven't been corrected on that yet, so I'm going to keep saying it until someone tells me I'm totally wrong. So the service provider can restrict runtimes, but responsibilities basically fall on the tenant. Needs to focus on the application and logic entities, while a provider takes care of the entire stack, hardware and sort of OS and platform wise up until runtime. So the attack surface, again, is going to be, largely speaking, application logic bugs, and bugs specific to the platform in use. So we've got a case study here where we were performing a pen test on an application which was actually hosted using AWS Elastic Beanstalk. And we found the application itself was vulnerable to SSRF, server-side request forgery. What that meant was, because it was using Instance Metadata Service version 1, in fact, this was before IMDS v2 was released, you could get the application to interact with the metadata service on your behalf and then return the results back to you via this vulnerability. So we were able to query that and pull out metadata details, including the account ID, the region, the temporary security credentials, and so on. Now, in this instance, I mean, our enumeration script also didn't exist at the time, but in this instance, we ran a bunch of queries and we weren't able to read an S3 bucket list. So we weren't allowed to run AWS S3 API list buckets. This command, we weren't allowed to run that, which meant we couldn't list out the buckets from the account. However, because of the nature of Elastic Beanstalk, it creates all of the infrastructure surrounding the application in a predictable way using predictable naming patterns. So we were able to enumerate that bucket name using only the information we had and the account ID in the region. We found a bucket. I say we, I wasn't on this test, but I'm just going to say it like we, because it's this company. We found a bucket which contained source code for an application. We found we were able to retrieve that source code, modify the source code, and in fact, we were able to write it back to the bucket. So we were able to overwrite it in the bucket with the permissions that were associated with that key. So it's quite interesting that we were able to interact with and in fact have write access to a bucket, even though we couldn't run a list buckets. But fortunately, we were able to find them purely using that predictable naming patterns and a bit of fuzzing. And it turned out this organization also had a CI/CD solution in place, something Jenkins-esque, which actually took those updates to the code. And this S3 bucket must have been sort of like the final point for deployment, because it automatically pushed our changes to the official website. And so we actually had a shell on the company's site. So there has been a bunch of research done into identifying these naming patterns, because it's a very, very interesting area of research, being able to find buckets based on application names and things like that. So if cloud storage is an example of platform as a service, we know that all providers have a service. AWS call it S3, Azure and GCP just call it storage. Data is basically stored in blobs. What does that mean? Well, it's potentially JSON objects or something along those lines. You can quite often host a static website from cloud storage. And it's worth knowing that the storage names, generally speaking, are unique across the entire cloud provider globally. They're not just unique per region. My mouse is gone. Totally gone. Okay, that works. My mouse doesn't. That's one that's never happened to me before. Still connected. get into that then.
Do the old take the battery out, rub it, and put it back in again.
It has not got an independent battery. It's Logitech MX Master. It's like obscenely expensive mouse. Let's try that. That should force a reconnect. Worst case, I have to use a trackpad, but that's really annoying. Okay, I might deal with that in the next break. Cool. So, storage names generally unique to the entire provider, globally, not just regional. But they do often follow predictable enumeratable patterns depending on how they're built. There are 3 common access modes for cloud storage. It can either be world accessible, which is effectively unauthenticated anonymous access. It's usually referred to as public, but for reasons I'll explain in a moment, I would argue that that's a bit confusing. So world accessible anonymous access basically means I don't need to be signed into anything. Your bucket is entirely exposed. I can access all the data. You then have what's called authenticated access. And this is where the naming is really, really bad. Authenticated means I need to be authenticated to an account with the cloud provider. Any account, not one related in any way to the project, not one in any way related to the organization. Any account with that cloud provider. Now, because anyone can sign up for an AWS account, a GCP account, or an Azure account, that means that is also public access. It's public, it's just not anonymous. And this causes a huge amount of problems because we see people we've known for a long time about this massive issue with public buckets, anonymous access. They can be spidered by search engines and so on. Sorry. But we're now seeing a whole new slew of problems with people who've set their buckets to authenticated, thinking that means, oh, I need to be authenticated to my account. But it's not. It's literally any account. As long as I have authenticated with the provider, I can access them. And that is nuts. I cannot see a reason for that existing, but there we go. So the only one that provides any protection is being restricted to a specific ID. Oh, mouse is back. So that is weird. Restricting that specific IDs, you need to grant access at an individual account level, and that is the only one that gives you any security at all. So if we can list objects, that's bad. We can obviously read what's in there. If I can write objects, I can overwrite your data, and that's horrendous. So the attack surface then, mostly it does revolve around permissions, both in terms of things being made well read or write access being granted, restricting down to an auth user, and that being any auth user, or us getting hold of permissions that allow us to access your data, maybe because we compromised your Lambda function, as we've just done, that sort of thing. Now, this can happen to anyone, to be fair. So this is a report on HackerOne, which relates to HackerOne. So researcher discovered an ACL misconfiguration existed on a HackerOne owned S3 bucket. It was a really unusual one because no read access was permitted. It was locked down for read access, but any authenticated AWS user could write to the bucket. And that meant that an attacker could theoretically post a file into the bucket, and potentially at some point someone might access that thinking it was there intentionally. So they fixed it. And what was great about this is it led them to audit all of their other S3 buckets, and they found a number of others that required changes too. So a well-deserved payout, probably should have been more, to be fair, although it was not a complicated issue. The impact was potentially enormous. So, right. I thought I could ignore it, but it was very distracting. My phone started ringing. There's the trouble. You set it to silent, but my watch still buzzes. Okay, so for AWS, accessing buckets is by means of s3.amazonaws.com/bucket name or bucketname.s3.amazonaws.com. I have still, several years in, never figured out what the rhyme or reason is to why it might be one way around or the other, but it will tell you if you get the wrong one, so it's really not a big deal. You can enumerate buckets just by attempting to access them. You will get either it doesn't exist or access denied or access granted. So you can tell whether they exist or not. For the REST style URL, you now need to have region tags. So that's s3.region.amazonaws.com/bucket name. And you might think that given there's 20 something regions that might slow down enumeration. But because of the thing we mentioned earlier, that they have to be unique globally rather than just per region, you can actually put any valid region in, and it will just tell you that you've gone for the wrong region, and it will tell you what the right region is, which can actually be very handy for us because it means we can establish what region an organization's project is working in. So that's what enumeration looks like. And you can see we've gone to this format, and it said the bucket you're attempting to access must be addressed using the specified endpoint. And it's shown you the other format. Similarly, we went US West 2 and it corrected us to US East 2. So it really does tell you everything you need. Because of the infamy, shall we say, that the S3 bucket issue got, sorry, that was weird. My mouse wheel went all loose. It's got a mind of its own today. There have been a lot of open source scripts brought out for brute force scanning, looking for storage buckets. So we can list a few, but there are way, way more. So the one I'm going to say that is worthy of mention is Grey Hat Warfare's bucket. What do they call it? Buckets.greyhatwarfare.com. Because it is continuously scanning and trying to pick up all the buckets it possibly can. And that means that instead of us sort of actively interacting with the APIs, fuzzing, trying different terms, we can just filter, effectively making our search a bit more passive, closer to sort of OSINT type level. So it's a very interesting tool, well worth a look at. GCP is a similar story, so you can access those at googleapis.com/storage/v1/b/bucket name. And the API is actually so close to identical to the one you'll get from AWS that I can only assume they came from the same open source software or the same person worked on them, because they are really close to identical. And similarly, open source scripts do exist, although they didn't get quite the level of infamy that AWS did. So there's GCP Bucket Brute that's worth a mention, but you can just use the GSUtil client and it will do the job, to be fair. With Azure, it is storagename.blob.core.windows.net/container. And pretty much as with everything with Azure, it is slightly more complicated to interact with. You need a bit more information, but you can, if you're authenticated to the AZ command line tool, do an AZ storage account check name. And effectively you're saying, is this name available for me to register? And it will say yes or no. So that's as good as any other enumeration method. You can also enumerate container content with a brute force attack if you've got access to it like this. And there is a rather neat tool out there called Microburst, which can do storage, blob, and service enumeration for Azure. Now, Azure stands out a little bit for another reason. So the Azure storage account can contain blobs, queues, tables, and files as storage types. And you can create URLs, they're called SAS URLs or shared access signature URLs, which allow you to grant access to external users to the contents of your storage accounts. So they look like this, and you can actually use them. So for example, if I set up a website and I'm hosting my images in my Azure storage, instead of making the storage public, I can use SAS URLs to access those images directly in my image tags. So I've got a bunch of parameters. You can specify the storage version, the types of services that are going to be available, accessible using that SAS URL, the signed resource types that are accessible, the permissions you intend to grant, read, write, delete, and so on, an expiry date for your SAS token. You can also set a validity start date if you wish. You can specify IP addresses and ranges of IP addresses to allow only certain people to access. You can specify a protocol, so only allow HTTPS or allow anyone, and the signature itself. And what we discovered was that you can take those SAS URLs that you find on the internet, wherever they are, whether it's my example of using them in image tags or whatever. You can obtain a SAS URL and you can load it into the Azure Storage Explorer or some other similar tool and identify all of the assets available. You may find, if it is the default storage account, which is created with any project you create in Azure, that the code for Azure functions is stored in that default account. So when you create an Azure project, an Azure storage account, a default Azure storage is created as part of the project, and project related stuff is stored in that storage. That shouldn't be a problem because it's all private. But if you start using that container and create SAS URLs, you're potentially exposing that stuff. And that could include the source code of your Azure functions. So if we gain access to that, we could potentially plant a backdoor, and then the next time that function gets invoked, we've got a backdoor running inside your environment, all through storage. So once again, anything but simple. So if you have a look at that storage bucket, or those storage buckets that we just found, so going back to this stuff, configure your Azure command line tool. I've given you, in fact, I will give that to you now in the Teams general chat, my little shortcut, because it's not in the solutions portal. If you have a look in the general chat now, you'll see that I've given you a request you can use and then a while loop that you can run to export and effectively configure your AWS command line tool. Using that tool, you should be able to gain access to the AWS API and read those buckets that we just identified, and you should be able to find and retrieve some sensitive files. Bit of a hint that will give you further access. So I will start the process. It is always worth rerunning this command anytime you start a new exercise. The reason being that these tokens, they're temporary tokens, they do expire. You get a fair while on them. But as I say, by refreshing them, you know that you've got the latest, and that should show up that you've set those in your printenv. And if we, once again, just double check that it's working by doing an SCS get caller identity, whoops, that confirms we're running with that assumed role, which means we should be able to run individual commands like S3 API list buckets. And that confirms this is the exact same set of buckets that we just saw from our enumeration script. So you can search through those, search through the contents of them. You can use AWS S3 CP to copy files out of those buckets to your local machine. And then you should be able to figure out that there's something going on and you might have access to another service. And that's what the next exercise will be. So no more spoilers. Let's whack 10 minutes up. We are heading for an early finish today, you'll be pleased to hear. Cool, good luck and have fun. Right, sorry about that. You got some extra time on this, which is great. That's how I'm going to sell it. So, oh, support, has that been dealt with? Hopefully Pratik has seen that. Awesome. Right, sorry about that. So let me grab those sensitive files. You will obviously, and I'm sure you have, searched through all of them, but I know what I'm looking for, so I'm just going to save myself a wee bit of time by taking a look at Not So Fruity Pen file, which kind of stands out. The name certainly should stand out. You can do a recursive list to theoretically see everything on there. And then you can just do an AWS S3 CP to retrieve EC2 user and EC2 user.pub. And if we cut out EC2 user.pub, it's clearly a SSH private key, and it appears to be for a user, EC2 user at tested.notsofruity.com. So once again, more on that in a bit. But that is platform as a service pwned. Hooray! Woo! Let's move on. Just a quick word. So I've mentioned AWS taking a lot of flack over the public S3 issue, and it's a difficult one because while it could be argued and has been argued a number of times that AWS could be more clear in their wording about things, it's not actually their responsibility to stop you from making stuff public that you shouldn't be making public. It is absolutely on the people who've done this. But AWS, to their credit, have responded well. They've now made it so you've got to click through about 60 prompts before you can make something public. Every time you upload to a public bucket, they warn you, this is public. Are you sure you want to do that? And even afterwards, if you take a look at the permissions, the bucket, it's got like orange warnings everywhere letting you know that you've made this public, and are you sure that's what you meant? So container as a service next. So this is brilliant for the service-based architecture, which is kind of feeling like the future at this point. It is definitely the way things are going. You can bring your own container, run it in container as a service. You can use Docker on its own or Kubernetes hosted environments, and each service, each provider has got a number of services for doing this. In terms of responsibility, then you need to focus on your images, your applications, your logic entities. The attack surface then is likely to be Docker image level issues or application logic bugs inside whatever it is you are running on Docker, and then platform specific focused bugs. So clickety click. I've mentioned, and so we kind of skip across it, but I mentioned before about the registry, and if I gain access to your registry, read access, I can read your sensitive data, write access, I can potentially put backdoors in your images. This becomes even more relevant because we've talked about stealing tokens. If I'd run through this this enumeration process and found that I had access to the container service, then I could potentially read your registry using these keys. And that's the sort of way that we gain access to people's container registries. Infrastructure as a service, this is where we have direct control over a VM. Functionally speaking, it's very close to on-premise. The only difference is that the VM we're interacting with is not on your infrastructure, it's on the cloud infrastructure. That's literally it. So it is the most flexible. It gives you as the tenant maximum control, but do I trust you, the tenant? Less than I do most other people, probably. So you need to maintain and update to that virtual machine OS and everything above it. You need to harden it, you need to keep it up to date, and so on. So it's the same attack surface. We've just done 4 days of infrastructure hacking. It's unpatched machines, it's shared credentials or insecure credentials, it's software and application flaws, it's misconfigurations. Really, the cloud-specific attack surface is basically that if I gain access to your VM, I can also query the metadata API and potentially steal tokens and get further into your cloud environment. Realistically, that is the additional attack surface. So it's the same old infra bugs. It's all infrastructure bugs related to hosts, VMs, whatever. any insecure practice that could lead to server compromise. But also, let's not forget that if you're running infrastructure as a service, you're presumably running it for a purpose. It's probably running some internet-facing application. So application level flaws are also absolutely critical here. So as I promised you, shameless plug has arrived. Our advanced web hacking course covers this stuff. We're now talking about, you're running a web app, whatever you're running it on, I don't care. If I can abuse that web app to give myself code execution or something, then I'm in a position to start attacking, for example, the metadata API. So our advanced web hacking course goes into that sort of stuff in great detail. So I'm going to just leave that at that and move on. Just a word I mentioned about firewalls. This is the AWS security group's screen. And this, sadly, is a site that we see far more often than we should. It's probably been the case in most people's environments at some point. Someone creates a security group with a ambiguous name like test and an ambiguous description like test. And then they open all ports to all sources across all protocols. It's something that you might do as a developer if you are in the very early stages of messing with cloud and you want to just understand what's going on. You go, oh, well, let's not let anything get in the way right now. But what happens is the next time you launch an application, it asks what security group you want to use. And you think, oh, I haven't got time to define a security group right now. Let's just grab one that's already on this list. That one's been used. That looks fine. And you grab it. And when you select the security group from a drop down on a list, that's pretty much all you see. You don't see this. You don't see the actual ports and protocols and IP ranges that you're applying. And so you're there's a degree of separation between you and the horror of this. And then someone else will do the same thing. And then you've got an environment full of in development applications, but that are open to anyone. And then at some point someone says, hey, let's deploy this. And the person responsible, they don't want to break anything, so they don't make changes like messing with your security groups. They assume that you've done that properly. And ultimately we end up with stuff going into to production with security groups assigned that make no sense at all. Because of those degrees of separation, you just don't see this stuff unless you go in and audit. So it is a very dangerous thing to do. It's a dangerous thing to set up in the first place, but then it's made worse by the fact that people are careless and don't audit and don't check what they're applying afterwards. So hard to say who the blame should lay on there. All right, so you've got a SSH public and private key. It's fairly clear what they are. So let's see if we can use those to connect to an instance. You should be able to find the instance. When you connect to the instance, you should be able to explore the metadata API. From there, you should be able to bring out some temporary credentials. You should be able to enumerate those, which should allow you to elevate your privileges within this AWS account and gain access to, huge hint, a hidden secret. Where might I hide a hidden secret? It's just a hash and you'll decode it. And I'm going to tell you now, it's the most disappointing flag you've ever seen. It's not an exciting hash when you decode it, but there we go. It's the final exercise of the course, and we just wanted to leave you with a bitter taste in your mouth. So I'm going to give you a few minutes just to see if you can get connected. If you can't, don't panic, because I will demonstrate it and then give you some more time. Good luck and have fun. Okay, so quick demo then. Where am I? Where am I? Who am I? If we take a look at tester.notsofruity.com, we can see we have an IP address, and we have quite slyly, if I do say so myself, made it so you didn't spot this earlier. But the public IP address, there is an EC2 instance operating at the other side of that domain. So it seems pretty likely that we can connect using those private key. So we will set the permissions, otherwise it won't work. We will connect to EC2 user at tester.notsofruity.com, and sure enough, we're able to connect. It's worth noting, if you weren't already familiar, that the default user for almost all Amazon machine images, Linux machine images, is EC2 user. Now, turns out, cruel people we are, you're in rbash. Now, of course, you can use the same breakout if you wish. You can go in and you can do -t bash no profile, and that'll allow you to have a look around. And there's definitely some interesting stuff, as you can see over the years. Various attendees of this course have let us all know that they were there. I've no doubt some of those are probably very rude. You can also just perform your enumeration one request at a time. So I can just say connect and only run a curl request to the metadata API. And let's say, all right, let's go to latest next. Metadata. Cat's back. Meow. Meow. Hello. Opie cat. And so on, you get the idea. But what if I showed you something really cool? And I like this one. I'm going to run a dynamic port forward. And I'm going to forward 1, 2, 3, 4, 5 on my Mac to go through this. What that means is anything I browse to on my Mac will be requested by this host. What's that going to look like? Well, loaded, but I can't tell where. Oh, there it is. Hey! I've got a really cool extension in Firefox called Foxy Proxy. If you haven't got it, you're in my jumper. If you haven't got it, you should absolutely get it. It allows you to configure multiple different potential proxies. So I've got one here called Socks, and if I show you in edit, it is a basic SOCKS4 proxy, which forwards through 1, 2, 3, 4, 5. It's literally as simple as that. So you make sure that's active, and then I can just browse the metadata API as if it's local to me. How cool is that? There we have everything we need. So we can do export AWS Access Key ID. Region. Secret access key. You can see why I don't do stuff manually. Session token. That is all the way down to there. And then just to confirm, STS get caller identity shows we're now running as assumed role EC2S3 full. So once again, I can run AWS service enum. And this is going to take a while because it's got lots of stuff that it is allowed to query, starting here. And I should probably give you fair warning. It's going to find snapshots. It's going to find tons of snapshots. They're not actually owned by this account. They're just ones that it's looked at. So it goes on for quite a while. So let's give you, there they go. Look at all those snapshots. Let's give you a few minutes to get yours running, and then we'll gain access to the secret that it shows us. Yeah. Yeah, so I was on mute that whole time. Cool. Okay, right. Try. I'm going to try that again. All right, where had I got to? So, what I said was through all of the output, we've got one that shows us we can interact with the secrets manager. So we can run a secrets manager list secrets, and it says there is a hidden secret file. You can, I've never worked out why you would, but you can describe secrets, which tells you more about it, but doesn't actually give you access to it, is effectively almost the same output. But there we go. So you can then do a get secret value, and that's the one that gives you the value. There's your hash. And sometimes you don't need to crack a hash. Sometimes you can just Google it. So I just Googled that hash, and it turns out it's the MD5 of the word password. So there we go. There is that. My plan was to give you another 5 minutes just to make sure you've had time to have a proper play with the secrets manager. So let's put that back up while I go and deal with the embarrassment at not taking mute off. Have fun. So I drag us forward. My goal is all of the exercises. We've pwned everything. I'll explain that one later. Um, I've got a couple more sections to run through. So I've got a bit on snapshots, a bit on identity platforms, and a bit on post exploitation. I think that's about it. There might be a bit on the other thing, shadow admins and stuff like that. If I can get that done, it may take slightly over an hour, so we might run into what would be the break time. But if I can achieve that, then we can actually finish really quite early. How does everyone feel about that? If we run into the break time but finish early, is there anyone that would object to that? Anyone that's like, no, I have to take a break at 4, otherwise I'm just going to collapse from the sound of your awful voice. I'm going to let you have a think about that. So snapshots next. Snapshots provide a way to take a point in time backup. We're probably all familiar with taking snapshots of systems. We can then restore from those snapshots if anything goes wrong. Within cloud, those snapshots will be private by default, but they can be made public, whether that's through intent on your behalf, or whether that's through someone gaining access to the permissions. They would need to take your snapshots and make them public. If a snapshot is public, then it can be cloned. It can be cloned out of your account and into somebody else's user account. At that point, it's in their account. They are now the owner of their clone of your snapshot. And that means they can turn that snapshot into storage, mount it, and they are the full admin. They can read everything. They can read your SAM database, your etc shadow file, your config files. Everything can be read unless it's encrypted. So the only protection against this really is encrypt your snapshots and encrypt your data at rest. But if someone manages to pull your snapshots out, that's the sort of power they have. So in AWS, you can do a describe snapshots for a specific owner ID. In GCP, it's compute snapshots list. And then it's a fairly involved process. I will just say, be really careful. There's 2 ways of doing this. One is to clone the snapshot, turn it into a volume and mount it to an instance you have control over. Or the other is to take the snapshot, turn it into a machine image and launch an instance based on it. Be aware that you could find you are the one being backdoored if you do that. If it's a sort of an intentional sort of double agent snapshot, you could find you end up backdooring your own account. So just be aware of that and be very careful about how you go about doing things. It is a very involved process, just to warn you. We do it at length in our full cloud course. Next is identity platforms, and we're going to start with Azure Active Directory. So this is a massive topic, but we're going to cut it down to just what I can fit in here. It is nothing but an identity authentication platform. It's nothing more than that. It is not full Active Directory in the cloud per se, but it can be integrated with your on-premise Active Directory. Basically meaning that users can authenticate using their on-premise AD credentials against all of the online services like Office 365, SharePoint, and Azure, but also loads of third-party services that use AAD as a supported authentication platform. So integration with on-premise is done through either password hash synchronization, pass-through authentication, or AD federation service. And it will look a bit like this. So you've got your on-premise Windows Server Active Directory, which is used for authentication with your on-premise applications. And you have Azure AD Connect, which is performing some sort of syncing, depending on which one of these you've used, with Azure Active Directory. And then Azure Active Directory can be used for authentication with the same credentials to cloud applications with external identities and your own business applications in Azure. So if you have any kind of Microsoft account, it doesn't matter if it's just a basic Office 365 account, it doesn't matter if it's purely for interacting with emails. If your account is linked up to the domain, you are enrolled in Azure Active Directory. And as a low privilege AAD account holder, you can perform all the various functions. You can interact with Azure CLI. You can query role members. If you go and check out portal.azure.com while logged into a Microsoft account, you may well find you've actually got GUI access to Active Directory. If you go to myapps.microsoft.com, you will find there's a list of third-party apps that you are allowed to authenticate to. There may well be some surprises on there that you weren't even aware of. If you've got valid credentials, then all you need to do is run an AZAD user list, and you can dump out all of the users in your Active Directory. And if this is synced up with on-premise, that will be all of those too. And if you want AZ/AD SP list, that will give you all of the service principals, all of the application accounts. So the most common way of integrating is password hash synchronization, PHS. So what happens is Azure AD Connect uploads all the hashes from your on-premise AD into AAD. So that means there is an AAD Connect sat in your on-premise environment with very, very high privileges that allow it to access the hashes stored in the DC. Therefore, a compromise of your on-premise AD Connect server means you could throw any hash you want, any account details you want onto AAD, because it syncs in that direction. You could just tell AD Connect to upload stuff and give yourself any account you want in AAD. If your compromise isn't quite as complete as that, but you can add users on premise, then there's the possibility to take over an account. If an account exists in Azure Active Directory but hasn't been created in an on-premise AD, then because of the direction of sync, then if an attacker can add that account to the on-premise AD, they will automatically be linked up, and the hash from AD will be synced to AAD, meaning you can then take over that AAD account because you've overwritten its password. And this particular issue was discovered on a red team by a guy called Dirk-Jan. They'd been asked as part of a red team exercise to see if they could gain access to the CEO's Office 365 mailbox without being able to physically access any machine that he uses. And Dirk-Jan at the time said, well, that's not possible. We'd have to hack Microsoft. That's clearly not in the remit. But it turned out that actually they discovered this method during the attack, during the exercise. And they were able to take over an Exchange admin that existed in AAD and set themselves up as delegated users on the mailbox. So they actually reported it to Microsoft, and Microsoft's response was to disable it for admin accounts. So you will no longer be able to take over an admin account. Anyone else's fair game. I don't understand Microsoft's logic, but okay. Next thing I want to talk about is application service principals. So service principals are accounts for applications. A default Office 365 environment, for example, sets up about 200 service principals. Because they're not for users, you can't MFA them, so they can't be protected in that respect. The idea is just that they've got machine-generated passwords, so we're not going to be able to go and crack their hashes. An application gets its permissions in one of two ways. They are either delegated from the user that's signed in using the application, for example, its ability to save to your storage, or they are assigned to the application itself via the service principal. Now, by default, as a user, anyone can create an application and create service principals for their applications. So let's say you build an application, you make a business case for it, and you get administrators to grant whatever privileges are required to the service principal that you've assigned to it. That all sounds absolutely reasonable. It's the right way of doing things. They're not giving you those permissions. They're assigning them to the service principal that's assigned to your application. Trouble is, if you own the application because you created it, that means you own the service principal. So you can actually impersonate the service principal and use any permissions that are assigned to it, including not just all of the AAD permissions, but all the RBAC roles, like the ones used by Azure Resource Manager. So those actions will actually appear in logs as they were performed by the app, not by you, which is also hilarious. Even worse, there are global or company admin accounts which can do everything. But in order to break that down so that you didn't have to make everyone effectively a super admin, there are some limited admin account roles that also exist. Things like application administrator, authentication administrator, exchange administrator, and so on. And these are limited roles, but they're fixed. So any application administrator can manage any application, which means anyone who's an application administrator can impersonate any of those applications, any of those service principals, and elevate their privileges. Again, this was reported to Microsoft. This was also discovered by Dirk-Jan, or his team at least. And Microsoft said, okay, well, we've disabled that for Microsoft apps. Again, everything else is still fair game. Last thing I want to talk about is seamless single sign-on. So you can combine seamless single sign-on with either password hash synchronization or pass-through authentication, so that basically where we've already got the ability to extend your existing credentials into AAD, we now extend the entire session. So when you would be presented with a login prompt, Instead, behind the scenes, AAD contacts your on-premise AD and retrieves a service ticket, which it uses to authenticate, so that you then go straight into being authenticated with the application. You never need to enter those credentials again. It uses Kerberos. We've talked a bit about Kerberos, and importing some well-known Kerberos weaknesses into our AAD environment doesn't strike me as the best idea. So AAD Seamless SSO uses an account called Azure AD SSO. Now bet you can't guess what it does. It encrypts ticket granting tickets using its hash at your on-premise AD. They are passed up to AAD where there is an account with the same hash, and they are decrypted. So if we gain the Azure AD SSO account hash on-premise, we can generate ticket granting tickets for any user SID we like and authenticate to AAD as any user for any service that those users are valid for. Caveat, if you've MFA'd those accounts, then they are safe. So MFA all the things. Is the hash of Azure AD SSO account never changes after your initial setup, and you can extract it using AD Connect Dump as one example. But it still gets worse. There is a thing called resource-based constrained delegation. What it basically means is you can configure it onto target objects. Now, any AD user with the ability to manage computer accounts within the container or organizational unit that Azure AD SSO resides in can configure resource-based constrained delegation on that Azure AD SSO object, and hence create service tickets to impersonate any AAD, any user in AAD. So when we think back to compromising KRB TGT, we had to get domain controller to do that. We needed like very, very high level access. This describes, I suspect, Kevin. So halfway through our compromise, we probably could have compromised this if Not So Fruity were using seamless single sign-on, AAD seamless single sign-on. So very interesting, very serious vulnerability there. From one identity platform to another, let's cover Cognito. So the Cognito service allows us to access resources as users of an app. So it's kind of, if you're an app developer, you can grant your app's users access to your resources within AWS. It's made up of user pools, which allows your individual users to sign up and sign in. And then it's made of identity pools, which enable you to grant all end users the same set of permissions to access your services. It's generally used for mobile applications, but a mobile application is just a web app with extra steps. So that applies to web apps too. And an identity pool ID is a random UUID, which kind of gives the impression of security, like it's difficult to brute force. It's kind of, it looks like a secret. It looks like a randomly generated security token. But the thing is, it's generally hard coded into the mobile application or the website. So I actually, when we first built the cloud course, I delivered it. And there were a couple of AWS guys in the room, and they came up afterwards, and I mean, humility was brilliant in general, but they said about this one that they felt we were unfair because the identity pool ID isn't meant to be a secret. And I sort of said, why do you make it look like one then? It's S3 all over again. We've given people the impression that there is security here, but it's not. By giving your app users access to your resources, what you've done is you've made those resources public. You've just done it in a way that doesn't look like that's what you've done. But you do need to realize that's exactly what's happening. Identity pools are public. It's public access. It's just that you've put steps in place so that you can't, it's not just going to get swept by anyone. So you've got two levels of access, authenticated and unauthenticated. But here we've picked apart a web app, and as you can see, we've got a variable I, which contains it's a random string. Turns out that is your identity pool identifier. And using the identity pool identifier, you can just go off and interact with the Cognito service. You can say, here's my identity pool identifier. Please provide me with a set of temporary credentials. And that's what it does. It gives you temp credentials, exactly the same format as what we pulled out of Lambda earlier, pulled out the metadata API on the EC2. It's AWS temp credentials. We can then use those to configure our command line tools to go off and do all of the same stuff, all the same enumeration. So this needed looking into. So there was some crowdsourced research done. Basically, a whole bunch of Android APKs were being decompiled looking for identity pool identifiers. I don't know exactly how many it took and how long it took, but ultimately 2,504 identifiable identifiers were collected. So effectively that is your sample size. 2,500 identifiers is your sample of identifiers. Again, I don't know how many identifiers exist in the world, but take this as a percentage of that and extrapolate when we get our findings. So they explored the permissions on each identifier, and they found that more than 1 in 5 of them was in some way insecure. What do we really mean by that? Well, there were 906 S3 buckets which contained sensitive information that should not have been exposed. So think like the app collects user data. It stores it in an S3 bucket using the identifiable identifier to get temp credentials. The developer thinks that's fine because you can't just access that bucket without the credentials. Only the app has the credentials, and the app will only ever retrieve that user specific data when accessing it. But the trouble is that is client-side validation. If I own the app, if the app is on my device, I can pick the app apart, I can retrieve those credentials, and I can go and I can perform manual enumeration, and I can query anything I want. So we're relying on the application not looking for something to secure it, and that's not how security works. So 906 buckets containing sensitive information that should not have been exposed. They also found 1,572 Lambda functions. That's okay, that's not a problem. Sharing those functions on the just completely public is asking for them to be constantly poked at and cost you money. So by putting them behind an identifiable identifier, all you're doing is sort of lowering the incidence of people poking at those functions. But the trouble is, out of those, at least 78 exposed sensitive environment variables. And immediately you should be thinking, oh great, another set of creds. We don't know just how far this rabbit hole would go. If we explored the permissions on all of those credentials, no doubt with that number, at least some of them would have led to a full environment compromise. Trouble is, at that point, we'd be breaking the law, so we just don't know how far this goes. Nearly there. Let's talk post-exploitation. So one of the first things that we need to think about is how we move between all these services. So we pulled out a token from AWS Lambda. We used that token and we were able to enumerate the level of access. We identified the level of access to that token through enumerating using our enumeration scripts, and we discovered that it had access to S3. From S3, we retrieved some more data, which we were able to use to gain access to EC2, and we were able to pull out another set of tokens, pivoting between more privileged accounts. We leveraged that access to get more of a foothold, and we ended up, again, through more enumeration of additional tokens, we had access to the secrets manager. So we didn't at any point get like admin access or IAM star credentials or anything like that. Our goal was, can we exfiltrate sensitive data? And that's exactly what we did. So we do need to be aware that the process of exploitation in cloud is not clear-cut path to domain admin or anything like that. It is about chaining together various different issues, gradually expanding our access, finding as many different sets of tokens as we possibly can in order to get to our goal. So we want to keep an eye out along the way for various different hidden resources. So that could be stuff like admin level accounts that were created but not used, or users with accidentally higher privileges, privilege to create policies and things like that that shouldn't be there. Services that got started up and not closed and potentially are out of date. Services that are in the wrong region. AWS used to be horrendous for this. You could be working in your dashboard, find yourself in the wrong region somehow, start up a service, realize you're in the wrong region, switch to the right region, and then lose the service and not be able to find it. I've had several people admit to that happening to them on my courses, so I know it's not just me. So shadow admins are not a new concept by any stretch, but looking in cloud accounts, it's definitely worth paying attention. So shadow admin accounts can be identified by searching and analyzing the permissions granted to that account. And an attacker can then use those to sort of stay under the radar. So we're looking for accounts with permissions that they're not like, hey, I'm a domain admin, because that immediately raises alarm bells, but instead they've got the sort of permissions that we can abuse to escalate our privileges, but we can stay quiet while we're there. So accounts with control over domain admins, or reset password functionality on domain admins, accounts with replicating directory changes all permissions and stuff like that. The stuff that's not quite a domain admin but has privileges. Similar sort of thing in AWS. There are some permissions in AWS that are particularly interesting that we do often find assigned to users where there isn't justification for them being there. So the ability to create access keys, the ability to create or update login profiles, put user policy, update assume role policy, they all allow us potentially to escalate our privileges very, very quietly. So this has happened before. So in AWS, there are lots of default roles that exist. So for each service, there's probably like a full access policy, maybe a read-only policy, and various other policies. And you're quite aggressively encouraged to try and always use the defaults, because to be honest, it is really easy to mess up when you're assigning policies. You can end up giving people access you shouldn't, maybe stuff off this list. So we tend to rely on the defaults where possible. And there is one called Amazon Elastic Transcoder Full Access. But the original Amazon Elastic Transcoder Full Access policy included IAM put role policy permissions, which allows you to attach inline policies to roles. That has nothing to do with Elastic Transcoder. It should not have been there. AWS eventually realized this and fixed it by rolling out a new policy on Amazon Elastic Transcoder _ full access. Why did they do that rather than update this? Well, it's because they didn't want to break things for people who were actually using this policy, including that permission. So you can no longer set that on new IAM roles, but if you ever discover an IAM role that has this assigned, it's presumably a relic from before this was changed, and it probably has IAM put role policy permissions, so it's definitely of interest, but it's certainly not obvious. Fortunately for us, there are some open source scripts out there for identifying these. You've got AC Light, you've got Skyark, and you've got Cloud Tracker, are definitely all worth a mention. And so I've just got another case study, which will probably look a little bit familiar to you. So again, it was SSRF on a web app, and we were able to interact with the metadata API via SSRF. So we're able to read out the account ID, the region, security credentials, just like before. This time, using these credentials, we were able to do an S3 API list buckets, and we found an S3 bucket that contained PEM files for EC2 boxes. Yes, that is the inspiration for that exercise we just did. Enumerating those instances, we found some that held higher power roles, and we actually found one that allowed us to backdoor the AWS account, creating a new ID with IAM star, so we could basically do more or less anything. So once we've kind of got to the top of where we're going to get, which I think it's fair to say that probably is, we need to think about how we're going to maintain that access or backdoor the account. Now, if you've got access to a high enough privilege account in AWS, you can actually start generating your own STS keys, so security token service temporary keys, with an STS get session token, but that means you can set the duration on it. So we're quite used to these being temporary keys that don't last all that long, and we're going to have to keep going back to the same original exploit to get new tokens. If we're in a position where we can just create ourselves a long life token, we can use that to get ourselves back into the account anytime we want, and then re-escalate. The thing is that these session tokens, because they're temporary, they're not listed anywhere. They don't show up when you do a list access key command. When you audit your access keys, you won't find them. So really, really good for staying under the radar. Similar sort of thing in Azure is we can create SAS tokens with specific permissions. If we know that there's a function that we can mess with, we can give ourselves write access to a container with functions in, and so on. In AWS, you can create users and access keys. I would argue that creating users is probably one of the noisiest things you can do in an AWS account. They've got to be really not auditing anything at all to not notice that you're creating users. Arguably slightly cheaper, quieter would be to add an access key to an existing user. So again, in AWS, I know for certain you can have 2 access keys simultaneously at any given time. The reason for that is so that you can create your new access key and make sure it works before you delete the old one, to avoid getting locked out of your account. But that means they won't notice this until they either create an access key or audit. And you just don't know how often people are doing either of those things. You can also create new roles and attach those to existing roles. So if you've got a really, really good compromised user that you're confident you're going to keep hold of, you can just add roles to that user. And that's probably quite a quiet thing to do as well. But you can take all this a step further. And this is thanks to some research by a guy called Daniel, whose surname I can't pronounce. Really cool write-up on this. You can create a Lambda function triggered by a CloudWatch event rule, so that anytime a user gets created legitimately in that account in the future, an access key will be added to that user and posted to you at some external location. So if I was auditing and I saw user created and I confirmed that that user creation was legitimate, I'm not sure that I would actually even question if immediately after that user was created, an access key got created. I was like, yeah, they created a user, they created an access key. That's the standard process. So there is a decent chance that you can get that to stay under the radar. Similar story, create a Lambda function triggered by another CloudWatch event rule each time a role gets created and adds that role to your existing backdoors. You can also make that code react to the update assume role policy call so that if your backdoors are ever detected and removed, you can reintroduce them. And it takes a few minutes for this stuff to happen. So if I remove backdoors and check that they were gone, I might not notice that they've been reintroduced 10, 15 minutes later. So finally, and even further ahead of schedule than I thought it'd be, we are on to cloud mitigations. So we can actually perform various different cool stuff here. We can create a Lambda function ourselves, triggered by more CloudWatch event rules that actually detect malicious changes to our environment. So we do a demo on our full cloud course where we set up CloudTrail and then we go in and deliberately disable it. And we have a Lambda function. Well, we have a guard duty informs CloudWatch events, which triggers a Lambda function and an SNS notification to notify us of the change and correct it, re-enable CloudTrail. So some really cool stuff you can do with CloudWatch event rules. My bullet points have got messed up here. Make sure you do not use the root or admin accounts. Even back in, and I want to say it was like, I always say 2012, but I think it was even earlier than that. So AWS has been around since what, like 2006-07 time, I think. I created an AWS account not that long into the life of AWS, maybe a couple of years in. And even at that time, I followed a best practice guide, which said, you create your account, you log into that root account, you use that root account to create some IAM roles for all the various different tasks you might need to do. And then you lock that root account down, you set it up with multi-factor authentication and a long password, and you never log into that again. Its purpose now is only to log back into if you lose access to other parts of your account. It's there to rescue you if you're locked out. For everything else, you should be using minimal, least privilege access. So use IAM for everything. Delegate tasks down to a very fine-grained level. You should never be operating with privileges beyond the absolute minimum you need to complete the single task in hand. You can use you can use assume role policy to easily switch without needing to constantly log out and back in. But basically, at all times, you should be operating according to the principle of least privilege, including all your access tokens, all of your IAM profiles, all of your roles, your services. If a service needs access to read S3, don't give it full access. It doesn't need it. MFA all the things, and I do mean all the things. MFA everything. Disable access to the metadata API if you're not using it. So I've already talked about sort of AWS having IMDS v1 and v2, and you can enable and disable them separately. But if you don't need them at all, switch them off. You could actually block 169.254, 169.254 at a server level. You can block it using IP tables or whatever. Maintain external logs and have them in a push-only location. So, for example, an AWS CloudTrail can do this, and you can have it push into a bucket owned by an entirely separate AWS account, and that way people can't cover their tracks because they can't remove log entries after they've been created. Encrypt everything, both in transit and at rest, and don't just leave services running. Don't just block port. Close the services down. As you are building, you need to include hardening in that build process. It comes back to that age-old thing, security is a bolt-on. You need to be thinking about how secure things are going to be as you build them. Otherwise, it's always going to be an afterthought. Ideally, systems should be fully automated so that, for example, if something goes down, it can completely rebuild itself from like a virgin environment. So there's no messing with it. So no one's gone in and screwed with stuff. And along the same lines, you shouldn't be messing with stuff in production. If you have an error or an issue that needs resolving, you shouldn't need to SSH it in production. What you should be able to do is fix it in a staging area, confirm it all works, and then just redeploy the whole environment. Your environment should be able to survive a full crash and rebuild without losing anything. And if it can't, then think about re-architecting so that it can. At the basic level, there are some brilliant benchmarks for hardening in terms of your overall cloud vendor accounts, tenant accounts. So CIS have done some brilliant benchmarks. These are just for the account. Once you start operating at an individual service level, you're also going to have to think about how you can harden all of those, especially the further left you move on that shared responsibility matrix, the more responsibility you're taking on, so the more things you need to think about. Keep your creds safe. I'm sure I don't need to say that out loud. And then audit, and audit some more. And at each step, always compare, contrast, and resolve all findings. So there are some brilliant auditing tools out there. You've got CS Suite, which is cross-provider. You've got Prowler for AWS, which aligns, in fact, to CI security and more. You've got SkyArk, you've got Scout Suite, which is also cross-provider. You've got Azurite for Azure. And I think I've said this before, but I'm going to say it again. I am very much in favor of layering up. I don't think there is ever a justifiable reason for saying, well, I've used the best of the auditors, so why would I also use others? Yeah, there will be a huge amount of overlap. Of course there will. But if you're fixing all the findings, that you're not going to have any findings to worry about from that overlap. So you may as well just keep going, because there's always the chance that one audit tool is going to find something that the others didn't. And when that happens, you'll be very glad that you used more than one. Don't forget, if you are using infrastructure as a service, then you need to do more than the cloud level probing. You also need to perform a full OS level audit. So maybe Luna or Linux on Linux, and the Microsoft Baseline Security Analyzer and security toolkits for Windows. Here is just a screenshot of Scout Suite in action against AWS. It uses your AWS command line configuration. CS Suite in action. In case you're interested, the exercises we've done, so the last 4 exercises in the cloud environment, these are the services we've run through as we've been working that exercise. So you can see just how much there is involved in putting these things together. But we thought that would be an interesting thing to show you in case you have any thoughts about how that all worked. But that is kind of AIH pwned, or is it? Who's this little penguin peeking out from behind the pwn stand? Actually, you haven't finished yet. So as I said, a huge part of the value of this course is the 30-day lab access that you now have. If you are working on the labs during that time and you have any issues, this Teams that we've used during the training, that's going to be scrapped. The environment's taken down at the end of the course. So instead, get in touch with us by email. AIHtraining@notsosecure.com will come through to me as well as several of my colleagues. So there should always be someone to reply. There are challenges that we've intentionally left. So you know that you've got the Heartbleed Shellshock lab, you know you've got the MySQL and Postgres lab. There's also some VoIP challenges, which I'll tell you more about in a moment. You can use different tools and techniques to target various hosts. There's multiple ways to land shells on various different machines. There's bonus challenges. There's several machines that we got a shell on but never escalated to root. You should be able to root all of them now with everything that you've picked up, especially from the Linux module. It's also worth mentioning, we've got a whole bunch of other courses coming up in the new year. If we've whet your appetite, which I hope we have, for this kind of thing, then have a look at these. And as an existing delegate, you get a discount. Hooray! You can either use that code if you book online, or you can just get in touch with us and we will sort you out. This one will probably go through to my colleague Denise, who is wonderful. And so you can get in touch with us that way and say, hey, this is what I'm interested in. Check out our website. So this is a small sample, but check out our website. We've got a whole bunch of courses coming up over the next few months. We also have some webinars if you can't wait that long. We've got a few in January and February. I believe, I don't think any of those are me. I think my next one is in March, if I remember. But that's just, I mean, stuff from this course, really. So do feel free to register for any of those. They are free to attend. You just have to put up with us being marketing. And before I do the thank you slide, there is some additional course content at the end of the slide deck in your student pack. and that is a VoIP hacking module that basically it was in this course. We've taken it out of the course because it's a bit dated and we've got so much other content. The cloud content was just expanding and expanding. And to be honest, we couldn't deliver the course in the time that we have allotted for it. So VoIP hacking got dropped, but we thought, hell, why don't we just leave it on the end of the course? So that is yours to take away. And there is a host that you can mess with, which is what that final penguin, go back. That is what this host here is. So during your lab time, if you feel like it, you can go and you can poke away at that one. And I think that is about it from me. So I'll find my thank you slide. There we go. Thank you very much. You've been amazing. You've coped with 4 days of me with a cold, which is more than I would wish on anybody. I will just say feedback is very, very welcome. I hope it's come across, despite my cold, that I enjoy this course and that I want you to enjoy this course. I have thick skin, I promise. So if you have any feedback about ways we could do better, be better, anything you'd like to see in the course in future, let us know. And all feedback is very gratefully received, as long as it's at least vaguely constructive. I will ask you, this does go to my boss, please don't get me fired. Other than that, all feedback very, very welcome. That is it from me. Well ahead of schedule, don't know how that happened. Are there any questions, concerns, comments? Oh, I know I haven't said something. Please grab from the solutions page, and I'm hoping Pratik is racing me to do this. Yay, he's done it. All of these credentials. This solutions portal is also going to be taken down, probably, I'm going to assume tomorrow. Yeah, Pratik has just posted it in the, there you go. It'll be available till Saturday. So please grab these. You will have your student pack, and in your student pack, there are answer sheets that these are the passwords for. They cover all of the solutions in detail. You're not losing anything by this portal going down. You don't need to grab the pages off the portal because everything there is repeated inside the student pack. You just need these passwords. So please do grab those before it goes down on Saturday. And as I said before, if there are any questions once this has gone down and once Teams has gone down, please just drop us an email. There is no stupid questions. We are always happy to respond. If you want to grab me outside on Twitter, that's also fine. Whatever works for you. But the floor is now open for questions. If you are done and happy and you just want to go and have a beer, I will not begrudge anyone who wishes to leave now. I will just say once more, thank you very much. And then I'm going to hang around for questions.
Yeah, it's been good, Anthony. Thank you very much.
Thank you. Thank you for being designated loudmouth.
Appreciate it, yeah.
Thanks for the time, folks.
Thank you. Good night.